here. Welcome to Dapp Mentors, and today we are about to shoot the last tutorial in this series, which is Makes It 4. Okay, I hope many of you have been following the previous ones, and if you have done that, kudos to you. I congratulate you. Okay, my name is Darlington Gospel, and I'm here to teach you and help you transition from being a Web2 developer into a Web3. Okay, through all these teachings, the tutorials, and so on. In this teaching today, we want to build an event marketplace with ticketing feature. Okay, so people can come and create event, and others will come to purchase that ticket. What makes it interesting is that in this tutorial, whenever someone purchases a ticket, after that ticket has been used, okay, it can still become an NFT for them, in the marketplace. So it can be minted, and those people can use that, trade it, on OpenSea or whatever, NFT marketplaces there are. So it's a double reward thing. You understand? You buy a ticket and then you'll be able to. So there's a lot of use cases that surrounds this event ticketing, marketplace things. Okay, you can use it for any kinds of, you can even use it for cinema. Okay, in case you want to build a cinema ticketing system, you can do that. You can use it for anything that has to do with ticketing. The ideas that I have integrated in the smart contract will really help you, and this could be a very fantastic idea for your project as well, for those that are still doing academic works in universities, colleges and so on. So you're going to find this very useful. Integrating into all this tutorial a diagrammatic design of how the system operates, which gives you a leeway and much better advantage, to as you design your your project, architectural design, is part of this project. Okay, so if you're new to this channel, please hit that like and subscribe button, okay, and hit the notification bell, because this is kind of thing that we release here in this channel. And this particular tutorial today is sponsored and brought to you by Bitfinity, and part of the rewards that we're giving out sponsored by Bitfinity are in the description section. Okay, different tasks that ranges from winning a book, 1 month subscription to our channel, and 3 month subscription to our channel, to our Dapp Mentors Academy, where you can have access to various educational materials, ranging from books to courses. And these courses are surrounding every single course that we have on our platform, not just one or two courses, but all the courses we have on the platform are going to be given to you for access for free within those period. All right, so this is a limited offer, and once we have all the people that want to dispatch this free giveaway, this giveaway, once they claim theirs, we're shutting down that particular philanthropy. All right, and with that said, I want to further give you information about what we'll be doing today, as in terms of the technologies that we're going to be using. We're going to be using Typescript. The front end is going to be developed with Typescript to ensure that structure is given to our programming, and enhances maintainability, and just generally just introduce structure and bottlenecks, the chances of having errors in our codes. All right, so that is one of the things we're going to do. We're using Tailwind, of course, to design the interface. Okay, so the interface is designed with Tailwind, and one of the beauty about this tutorial is that you don't have to start from scratch. In fact, we are not starting from scratch by building interfaces and all of that. I've noticed in the time past that was one of the reasons that my tutorial had been long, and I don't want to keep you that in the game. Okay, so I had taken the chance and built the interface for you. So we have an interface already, and all of those. All we just need to do is to design the back end, which is with Solidity, and we hook it up with the front end, and then we show you that it works. Okay, and then you can use it for your learning and your advancement. So that is one of the things that we're going to be doing, and that's done with Solidity. And what else? We're going to need to use Redux, okay? Redux for data management, okay? We have a lot of data that is flowing in between different components and pages. So we need a central hub, a central space to store our data that is coming from the blockchain. And where we do that is, with Redux. So we have Redux being part of this, and of course we're developing all these tutorials with Next.js. So if you are a fan of React, you already are in the family of Next.js, so it's not going to be such a big deal. Everything is just going to be simple. All you just need is to follow the step-by-step of what I'm doing, and you will understand how to develop these things yourself. These tutorials, they also have written versions of them, okay? As this video is out, that written version is also out, and I'm going to link it to the description section as well. I've put this thing out there for you, okay? So as you use this tutorial to learn and improve, a little way you can help us is by clicking that subscribe button, share, and just make people aware that we have this place where you can learn blockchain development and all of this. And of course there are many more that we want to release on our channel. So this is what is coming in for this tutorial and in this channel as well. So don't forget that there are prizes to be won. Don't forget that there are other parts of this tutorial, other ones that we've previously released, so you check it out as well. Anyone that you like, you can start with that one. Everyone, I've used the same pattern to develop each one of them. If you're not a TypeScript fan, there is one of these tutorials in this series that uses just pure JavaScript. You can use that one to level up and chill off. Okay, so there's no excuse for anybody, so jump in and let's start coding. All right, I'll see you in this tutorial. So today, these are the things that we're going to be achieving in this course. I've already introduced this course to you, so you know the preambles, the details, what it's made of, and all of that. So you're in good shape on that one. This is the table of content I'm discussing with you now, so please pay attention. I'm going to start with the demo. I have to demonstrate this application to you. You see, one of the good things is that I've already deployed these applications and they are live on the Bitfinity chain. So I'm going to show you how they function there so that you can see it yourself. And afterward, I'm going to show you the architecture of this, design, and all of that. I'm going to show you the toolbox, the things that you need to be able to partake in this project. You need to install all those things, and I'll tell you about the project setup. So basically I'll show you how you set up this project on your computer so that it can run as well. Everything is just going to be like me holding your hands and walking you through it. Then I will explain the project structure for you, because this project that you're getting is not as if you're coding everything from scratch. So there are existing structure already in the application. So what I want to do is to explain what each folder means, what each folder means, what each file and what they do, and what you need to be aware of. So I'm going to let you know on all those, and we'll code the application next, step by step, the smart contract, the Redux, the integration with the interface, the testing, and all of those, the seeding. There is a lot of aspect that has to do with this course. So I'm going to show you how you do all those things together, and then we'll conclude this course and we conclude all the aspects. Okay, so the next thing that if you're seeing this, of course you'll be seeing the course on the site already, but at the time of recording it, then we have concluded this Bitfinity challenge. Okay, so this is it. So let's jump into the tutorial and start demonstration. Let's step into the tutorial and start demonstrating how this application works. All right, so this is our event marketplace, and you can see it's hosted live. It's hosted on, what's this place called? So that hosted on Vercel, right? And also when I connect this wallet, I'm gonna switch to Bitfinity, network, It's currently on hard hat, so I need to switch to Bitfinity. Okay, so switch to Bitfinity. So it's hosted on Bitfinity network. All right, so let's choose an account that has some BFTs. Okay, where are my BFTs? This is supposed to have some BFTs. Where are my BFTs? Okay, there you go. Okay, all right, so we can also connect this account and just verify. Okay, so right now here are some challenges. Okay, some not challenges, but some event that I had previously put in place. So I created them. How you create it is by saying add event, and then you add the details of that event. Okay, then you can create it. So let's do that from scratch. Let's look for some event marketplace. All right, so let's look for some tech event and detail them. Okay, which should we use? Okay, I'm trying to look for one with an okay image. Okay, let's just take this one, and for here I'm going to go to Pixabay because I want to use my own image. I call it You're Meant for More Virtual. Eventbrite. Let's look for another one. Tech events. Where are you? Tech. Or let's say blockchain. So let's search for blockchain event and use it. So here we'll look for blockchain image as well. Okay, so these are these blockchain event. Okay, look at this. This is blockchain and crypto. Okay, so I'm going to copy this link, paste it here. So let's look at some details about them. First, the name of the title is blockchain and crypto, so we can use that as a title here. The capacity, let's say 50 people are to partake in this, and the ticket is cost around 1.39 ethers. Okay, so you can, let's see if we can copy the image URL. Okay, so when you paste the image URL, okay, this is it. But we can also use a different image altogether. Yeah, I think this is dope. Copy this. All right, so let's use that as the image. Oops, that is not correct. So let's view it. All right, so copy the image from here. Come back. Okay. All right, so that's a clean image. So this starts on the 10th and then ends. Okay, please don't forget the time as well. So normally let's start from 9:30 a.m. all right, and we can close around, is it 2 days, 3 days or so? So we can close around 4 p.m. 4 p.m. All right, so this is the time, and now let's just grab some details. Okay, which is this. Copy that, paste in here. All right, and then let's click submit to create this. So our MetaMask is prompted now. Let's create that, and once it is created, you'll be notified. This is, by the way, we're using what's it called, Toastify, to do this. Okay, Toastify is responsible for that. And of course, when you come here, when you come back to the home page, you'll be able to see, okay, this is the information, and you can see that this is listed and it is open currently, so people can purchase. If you come to your personal event, you can see it listed here. So now what we want to do is to, let's switch account. Let's switch to this other account. All right, So let's switch to this other account and come and purchase some ethers. Right now, you can see that 50 seat is left. So say buy ticket. I want to buy 3 tickets, okay? Or let's say, okay, 3 tickets. How much would that cost me? Let's say 2 tickets. I will have another person buy a ticket. So let's buy ticket right now and confirm this. So tickets, once it is approved, all these details should, be updated. Okay, you see that is confirmed, and you can see that I've just purchased 2 tickets, and you can see that is 48 seat that is left, and you can see details such as is 1 day remaining, okay, and all of that. We can also have another person purchase a ticket. All right, so let's switch to this account. This is the original owner, so you can also buy your own ticket as well. So right, and because you're the owner, you have this option for more. You can pay out once the ticket is also over, and all of those sweet features we embedded that. This whole thing is just fantastic. So let's click on, let's purchase 1 ticket. Okay, so let's purchase 1 ticket, confirm. We're going to limit this so people don't purchase more than 2 tickets at a go, so we can keep it there. So you can see, this is being tracked now. You can see how many seats that are left. So yeah, so this is how it is going, and when the time comes, people can, you'll be viewed. Of course, your ticket is going to be viewed, and if there is any problem with it, if you're there, I honestly, there are other ways you can do this within your own infrastructure. So like, for example, you can print out something like a physical thing that can be used to validate whether a ticket has been used or not. So at the end of the day, all those that have purchased the ticket, this is not a refund process, so you can't come here and say refund. You can come here to see all sales. These are all the sales that have happened in this platform. But at the end of the day, once the payout is triggered, like payout happens, say click, error because it's not yet time for payout. Okay, so they've not even entered in, so you can't pay out anything. So these are the things that I'll see how clean and detailed this application is. Wonderful. So this is what you're going to be doing. All right, this is real life blockchain use case. Right, it's not only about NFTs and all that. I know that those has to do with money and all this, but there's also NFTs in this. Okay, this ticket, whenever you pay out, there are all these people that purchase this ticket are going to have NFTs minted to their wallet address, and they can do whatever they want to do with it. Okay, so that is it. That is how this tutorial functions. And in the next part of this video, we'll start, developing this. No, not developing. I'll start taking you through the phases of architecture and then toolboxes and all of that. So let's do that in the next part of this video. Okay, so this is how our event marketplace looks like. So we have event creators, which could be anybody that have an event that wants to list it on our platform. Okay, so the person can come here. He has to be authenticated with MetaMask. So once this person is authenticated with MetaMask, so with the buyers of the ticket as well, because any write request to the blockchain needs to come from a valid source that has authorized the transaction. So that is one of the things that is needed. And this person of group of people can create an event by triggering the event creation function, and that event is available on the marketplace. So buyers can come to buy the ticket. Okay, so they are ticket holders, that is what we call them. So each time they buy a ticket, it's under their account, and at the end of the day, we have a function. So once the event has been completed And at the time that the organizations want to cash out on their money, on the event, they could click this payout function. So when payout function is triggered, it's not only, it doesn't only give them their money, but also we mint free NFTs to all these people that partake of that event, so that purchase the ticket on that event. So they get NFTs. So these NFTs can then be sold on OpenSea or other NFT marketplaces, and all of this information will be captured on the smart contract and also be deposited on the blockchain. So people that visit our website will be able to see this information. So this is how the whole system works in a glance. So I hope you understand it. You can use this if you're a college student. You can use this could inspire you on what you need to do, okay, for designing the architecture. If you're not cool with this, maybe if you want to expand on it, you can borrow the ideas that I've already incorporated here. So that is just it. So let's jump into the next thing. Okay, so these are the tools that you need to have installed on your computer before you can run this project. Now, the first one, which is unnegotiable, is Node.js. Okay, I say this in all my videos. Okay, Node.js needs to be installed. Install the version that is compatible with your operating system, and I will recommend you install the LTL's version. Okay, not the current version. The current version is 21. I want you to install this version. It's more stable and very much compatible with what we're doing. All right, so once you have that installed, I want you to install VS Code if you don't already have that. VS Code will make this project feels like home to you. I don't want you to be doing something different from what we're doing and then having to pass through hoops. I don't want you to pass through hoops. So that's what I'm telling you right now. Get VS Code installed on your computer. Make sure you get it for any version of your operating system that you're using. All right. So by just clicking that button here, so I have that installed already, and you need Git Bash. Git Bash is going to be important for things that we're running, in this application. You see, I actually even Git commit on each phases as I keep progressing in the application. So I will do some Git commit and all of that. And some commands are just relatively, universal within this Git Bash. So if you have it on Windows and Mac, they kind of function the same way. So you need Git Bash installed. And also to clone this project, to clone the project that we're going to be using, okay, you're going to need Git Bash for that. If you don't have Git Bash, you're going to have to pass through another procedure, which I would not recommend for you. So get Git Bash installed for whichever operating system that you're using, and afterward you need Yarn installed. Yarn is very important. Okay, Yarn functions the same way as npm. Okay, Yarn is a package manager as npm. So this is how you globally install it on your machine, and it needs to be globally installed. And once you've installed it, then you can run yarn -- version to check and verify that it's working. And one way, and lastly, this is Dapp event. This is the project that we will be cloning. Okay, this project, I've documented them. I did quite a diligent work here to ensure that I have this project ready for you in this format. You can see the project has all the information that you need, everything well detailed, and how you can install it as well. You can even see a phase here called minted when the project has been completed and has been paid out. Okay, so you have different status there that is available. So these are all the key features that makes for the smart contract, and we also have the instruction for running this application, and one of them is these environment variables. I'm going to show you how you can put this and where you can get the environment variable pretty soon when I'm setting up this project. So all this information, including how you're going to run this project as well, has been outlined in the readme of this project, so get it there. So you can also see the online link to where you can see it. Make sure you start this project. Okay, start this project, and just make it much more, let it reflect that people are actually using it. Okay, so in the next part of this video, I'm going to show you how you install all this. But for you to verify that all the packages that you installed are working, what you need to do is to run you need to run this command. For Node.js, you need to do node-v, and it will show you the version of Node.js that you have. I'm currently using version 18 and it works fine. I believe that it will work perfectly as well for you. Okay, so use Node.js, and this is for git bash git -- version. All right, so you see that I have git bash installed, so you can verify that by also running your own if you had successfully installed yours. And then yarn -- version as well. This returns the version of yarn that you're using. Okay, VS Code is absolutely installed on this machine. You can see VS Code right here. So now I'm in line with you. So in the next part of this video, I'll show you how you can set up this project and flow with me. So I'll see you in the next video. All right, so have this project installed. We're not going to install everything, but look at this branch. This is the branch that we'll be working with. We'll start with this branch called no Redux. Okay, in this branch, I did not include Redux in it. I did not include blockchain in it, so it doesn't have those features. It's just an interface, a bare bone interface that has some dummy data to read, so that we can start from there and nobody has to complain about not knowing what I did or what did I not do. Okay, so we're starting from that place. So that's why we encourage everyone to make sure that they start from this branch. All right, so the first thing you need to do here is to copy this URL, come to the browser, to your terminal that is open. You need to cd to your working directory. So I put all my code on this directory. You can see previously built application, all of that. So I am definitely going to be deleting just about all of this. Once I'm done with this, I'm going to delete just about all these projects from my computer because they're already on GitHub. So now what I want to do is, when I run this, you can see that I had previously retained this project. So I'm going to say git clone this project, but I want this Dapp event YT. That is the name I'm going to give to the project folder. So I'm going to clone that, and this could take a while. Sometimes it's faster, so let's wait for it. Seems to be faster, so hopefully it doesn't disappoint. All right, I'm going to have to pause this video and proceed later on. Okay, it's done. I don't have to pause this video. All right, so now I have to cd into Dapp event YT. So I'm in this, and one of the ways, if you've configured VS Code properly on your machine, you can just simply do code dot and this project is going to be opened up on your machine. Otherwise, what you need to do is to just come here, look at it, and then drag it into this project here. So that's how you can do these things together. So with that said, okay, so these are all the things that pertains to this project. So let's set it up completely. To set it up, make sure that you're in the master's branch. Like if I do git branch now, git branch, you see that I'm in the master branch. So that is the place that we want to be. Now the next thing you need to do is to install this project. We have this package.json, all of these things inside of it. We need to have it installed. All right, and how you have it installed is by saying yarn install. When you run this command, you see I'm in the master branch. I did not install it on any other branch, but in the master branch. The reason why I'm doing this is because whatever packages I install here will be applicable to other branches as well. So because the master branch is the most updated branch out of it, So I don't need to install anything. So everything here that I've run and installed, you can see the node module is available already. All of this is all the things that I need to run for this project. I don't need to install any other thing for this project. And this is one of the ways that I found that it's quite useful and instrumental to teaching people, because while I was learning, in my earlier days when I was learning and all of that, one of the things that I encountered are version differences in these packages. But with this sort of way of cloning and navigating to those branches, you don't need those version problems. Everything is on point. So now I want you to check out, we have so many branches here. If I say look at this is the branch that we're trying to move to right now. So I want to say git checkout checkout into 01 underscore no underscore redux. All right, so we switch to that particular we are now in that branch. If I do git branch, you see that I'm in this particular branch. So this is the branch that we are. So, and let's do yarn dev to launch this project on our screen. All right, so once this project is launched, then we will be able, I hope, let me see. Okay, all right. So once this project is up and running there, let me see. Okay, so go to localhost, close up from these ones. So this could take a while because it's compiling under the hood. All right, so now this is one problem that it's notifying you project ID and all of this. This is as a result of not having our environment variable taken care of, just as we had earlier discussed. So I'm going to do code, open this, say code.env. all right, I'm opening this is the .env file. I thought we had this, or let me go back to this place. I'm going to copy this line of code here. I'm going to copy this script, this environment variable. I'll bring it to the code. All right, paste it. In fact, okay, this should be in git ignore, right? This should be, this is in git ignore, so it should be available across the other branches, even though I am creating it inside here. So this is going to be the RPC of our hard hat project when we're running it. This is just our local URL. This is the location, and this is some really secret thing. So these are just, this is instrumental when we're actually clicking on that connect button. It uses some of these details. Okay, it doesn't make sense to you now, but just leave it this here. And one of the things I'm going to encourage you is to study this project and just observe how I use each part of it with another. It's going to help you. All right, so now let's replace these ones with read data. And how we do that is, one will come to this place, Alchemy. We want to get some project information from Alchemy. If you are not, if you've not registered for Alchemy, you should do that. For some reason, all of these new packages, they're having dependencies with various providers, such as Alchemy. Now you can create a new project. Okay, once you create a new project, then it will be listed here. So you need to create a new project. Alchemy had done a lot of upgrades since then. It used to be pretty much straightforward and simple. You can come to app, and create new app. I already created all my application. So I'm going to use this demo API key. Look at this. This is the API key. I'm going to use that and replace this. I'll close this now. I'm going to use that to replace in this location. You get this? So this is one. The next thing I want to do is to come here. Look at this. This is for Wallet Connect as well. This is for Wallet Connect. It's another dependency. You need to go to this cloud.walletconnect.com and /sign in. If you're not signed in, you should sign in, okay, and create another project to get the API key, the project key, the secret key, attached to that project. It's going to also be required for this thing that you're doing. All right, so I'm going to click on this demo. All right, so I'm just simply going to copy this project ID and make sure that I replace it here. All right, see project ID and Alchemy. Okay, so now we have those two available. So when I do yarn dev, and it's going to insert that dot environment variable into the stream. You can see it's already loaded. Okay, so I could come here now, go to localhost. Once it is properly compiled, you can see it's compiling. So it's almost there. I think that is it. Okay, that is it. These are just fake data. Like you can see, some of them are minted, the status changed to minted, and so on. Okay, you can also see that there is something that there's a design clash here. Okay, that I needed to expand this a little bit so that it can accommodate this image properly. So we're also going to take care of that in a little while from now. So it's saying wrong network. We have all this network here currently. So I'm going to change this network. I'm going to remove this poly and polygon and replace them with one, which is Bitfinity. All right, so at this point the project is set up and is ready for use. So in the next part of this video, I'm going to explain the various things that makes up for this project, all this project setup and the project structure. I'm going to explain it for you. So I'll see you in the next part of this video. So these are the things that makes up for this project. This Husky and .nest are self-generated. They are generated here. We don't have anything to do with it, so I would suggest that you leave it alone. All right, this component is another folder, and this component comprises of all the various parts of this application. Like you can see here, we have the header, this is the hero, these are the cards. All these things are various components, okay, that makes up for this page. So that is what this folder contains. All right, and then this is node module. This is where the installation, that yarn installation, deposited all those packages there. They are not uploaded to GitHub whenever you run it because they are outlisted. They are blacklisted on this .git ignore. Where is it? Where are you? Where's that git ignore? Yeah, this git ignore. You can see that node module is blacklisted, so you can't put node modules online. And I'm glad they did it like that, because this node module is the heavy duty of this application. This is where all the things are deposited, and it's truly heavy. Okay, this is the pages. We have about 1, 2, 3, 4 pages. So no, we have 1, 2, 3, 4, 5, 6 pages. Okay, so we have these index pages, which is the home page, and is the one that you have been seeing here. This is the home page right here, and we have this personal page. This is all this page belongs to every event that you've created under your own account will be listed in this personal page here. This page here enables you to create a new event. Okay, so that is what it simply does. All right, we have this event single page. This is a single event page. It shows you details about a specific event. Okay, so and I think you can click that one of this right now. Okay, so this is a single event page. So you see that is how it looks. All right, we have the edit page. This edit page is responsible for editing the content of a particular event. All right, so and it's if you're the owner of that event, then you have authority to change it. Otherwise it's not going to allow you. That's one cool thing about this. We have tickets. This ticket page lists all the tickets that have been created, like come to all sales. These are all the tickets that are associated with that unique event. So people would have purchased it. Look at it here. So basically, those are the various things that makes for this project. No, for the pages. Okay, we have this API, this next auth. This next auth is used for, that verification message that we normally do. Like, for example, if I'm trying to connect to Ethereum, I switch here. Okay, let's say I'm disconnect. Let me disconnect from this. I'm going to disconnect all these accounts. Disconnect, and disconnect. So let's connect this. Connect. You see, I'm going to connect with this. You see this verification message that is required. Okay, this verification message is going to contact this endpoint, and this endpoint, we perform some verification along, credentials. This is what is responsible to authenticate your wallet. You understand? So you can see the address and all of those things are authenticated here. So when I say sign in, you understand, this sign in message is, pops up. Okay, and then I have to verify that this is my, Ethereum account. You can see how the message is. Ethereum want you to sign into your Ethereum account with this. Once you're signed all in, you'll be able to access all our Dapp's features. Okay, and you just do that, and you see that you're connected. And that is basically what this page does. It helps you to verify a wallet connection. We're using Sui messages to get all these things together. So that is the only API we're using there. And of course, if you don't know anything about this _app, this is a bundler. It bundles all the components and pages together. So that is what this is. It is the entry component for all the pages. All right, so this is public folder. We will not have anything to do with it, so you let it go. So this is services. We're going to have like 2 services in this application, but for now you're seeing only one. This is called provider. The provider is responsible for the wallet configuration. So you can see even the message that we're using, it comes from this place. This is a wallet as well. Okay, and I think I needed to switch into the master's branch because I'm missing in some of the essential folders. So we have screenshots, but it's not. You just let it go. It's just for documentation purposes. This is where we store our images that you see in that README. This script here, you see, I've also skipped a lot of important places. I needed to start from that master's branch to explain everything for you. All right. So this artifact is generated by Hardart. So whenever you compile your smart contract, this is where it lives. It lives inside this folder called artifact, and this folder contains your ABI. Okay, your ABI for your contract. So this ABI is what we use as a schema for interacting with your smart contract that lives on your favorite blockchain. Okay, so you will not have to work anything on it. Just let it be, and you won't touch it. Just let it go. All right, this cache is for, I think, is for caching the Solidity version. We have compiler versions. So whenever you do git compile or git deploy, it first of all compiles the code, and once it is compiled, then it can proceed. And before it compiles, it will first download the compiler for you, because whenever you do this, it doesn't come with the compiler automatically. You can see here that even us, we had to specify this is the Hardart configuration for configuration script, and it tells you the version of compiler that it's using, which is version 0.8.17. You understand? So this is where it is cached, so that you won't have to be downloading the compiler over and over again. I think so. Because whenever we run that, this is where Solidity caches that whole information. All right, so I've explained components. I've not explained contract. Contract is where our smart contracts will live. Okay, for now we only have one smart contract, and I also have made sure that the contract address also is deposited here. So for each time you deploy a smart contract into the network, it's going to generate this. This is not self-managed. We had to program it this way ourselves, and I'm going to show you how you can do that in this video as you flow with us. So this is the smart contract that details everything concerning this. We're going to code this thing ourselves from scratch so that you see how it goes. All right, so I'm going to remove that, and I've explained pages. Script are the various commands that you use to manage the smart contract used in Hardhat. So for example, this deploy script is responsible for putting the smart contract on the network. This seed script, we have designed it to generate fake data and pop it into the blockchain and seed it into the blockchain so that we can have something to work with as we start without having to start creating everything from scratch. It can be very tedious, especially when you are testing this thing. Okay, so that's what these scripts they do. Services, like I said, there is provider service which manages the wallet, and there is also this blockchain service. This blockchain service is responsible to serve as an intermediary between the smart contract that lives on the network and the interface, because it's through the interface that will communicate with the smart contract that lives in the network, and each one of those communications are going to be triggered by each one of these functions that are outlined within this blockchain service. All right, that is the purpose of this blockchain service. We have store. The store is going to be Redux basement. This is where we store our Redux data that is flowing from the blockchain and distribute it across the components and pages that are sharing this data with us. So this folder is responsible for managing that. Style, you won't have to do anything about it, just let it go. And we have this test. This test folder is responsible for all the scripts that we use in testing our smart contract to ensure that our smart contract actually works great the way we've built it to. So we will write all these tests too. Okay, and please, for this script and this test, I'm not going to include it in the YouTube video. Okay, it's going to be a video on itself on Dapp Mentors Academy for free, or you just need to sign in and you will see that video. Most people don't like engaging in this aspect, but this aspect is very instrumental, very important for a blockchain developer. So I will encourage that you watch it and you see how I test, develop, and I also did some modification to the smart contract. So the one that you see that I finished building, there may be some bug on it, but when you watch this aspect, you will see the completed aspect of it. So please look at it, and also consult the finished code on the finished version, especially of this particular one that I'm going to be building, the finished branch of this project that I'm working on, this YouTube branch that I'm working on. Check it out, see the smart contract, see the finished version of it. That is the one that you should be working on when we're integrating this code. Okay, so utils have some essential data that we need. For example, this fake data, we use it to generate codes, and that is basically what you see. All these data that are flowing, they are generated by those fake data, that fake script. So this generate fake event data, and this generate fake ticket data. Okay, that is what they do. All right, so we have this helper function. So this helper function, we use it for some things to just format some data, especially when it has to do with timestamp. Like you can see this helps us to know the expiration date, how many days that are remaining, okay, of an event. This helps us to format the way a wallet is structured. Like you can see here, this structure here is formatted by that. All right, you can see days remaining is also formatted by this get expiry date. All right, so we have format dates, various things, which you can see here, start on Monday and all of that. These things are done with this helper function. This calculates date difference. All right, so, and this is timestamp, date, local. So all of these things, they have their various usages in the application as you go. So that is what this helper function folder is for. We have this DT. These are the type interfaces, the interfaces that we're going to use in this application. I just put them in one script so that they will not be scattered all over this project. I like bringing structure into whatever things that I'm building. All right, so this is responsible for helping us to truncate a wallet address. Okay, this is for creating an event. This is for displaying events that comes from the blockchain. is quite different from the event param. This is the full structure of an event. This is the full structure of a ticket. These are the things that a ticket does have. All right, ticket has all this information, and this is global state. This is essential for. This is just essential for our store. You understand? So our store will be utilizing this interface for structuring how our state variable, our global state variable will be. And then this also will be used by our store as well for helping us to display data correctly. So those are the things that makes up for this. And what else have I now explained? This header, this is the script that configures how header will behave and manage your project. Okay, you can see that I've already added this. This is for deploying stuff to the Bitfinity chain. Okay, so this is the RPC URL. You need to enter your account private key in here for you to deploy to the network. You can add it as what is it called? You can add it as an environment variable. Okay, so you can add this as an environment variable. This is the chain ID. Okay, so this helps you to push something into the network. Okay, so other than that, the rest of the files, they are not very important. Okay, you're going to need this DT, which declares a certain package, which is this package that helps us to generate these unique identicons. Okay, so you need to declare that module. All right, so with that, that is all the things that you need in this project. So I'm going to switch back to that 01 place. Okay, so I'm in that branch again. So I want to create a branch specifically for this build that we'll be doing. So all these branches have been created before. I want to create a new one for this particular build. So I'll call this branch, say git branch, and call it YT for YouTube, and call it YouTube starter. So this is where you start. So I've created that. I'm going to check out into that. So git checkout. Okay, so you see why I told you that you needed to install git, because if you don't have git, you will not be able to do this sort of things that I'm doing. So you say underscore YT underscore starter, and then it switches to that branch. So this is the branch that we are going to be working from. So in the next part of this video, we'll start doing that. And please, before you move forward, okay, before we move forward and do other things, I would like to do this quick changes. Okay, this quick changes. Let's come to the master branch. If you're in the master branch, you find out that we have a configuration that is a little bit different. Like we have a configuration for Bitfinity chain. So I want you to copy that configuration. This configuration includes the chain ID, the Bitfinity network, all the details that you need to have that network. See, well, right now we don't have that here, so we need to replace this with that. So to do that, you simply copy this Bitfinity chain information. All right, so once you copy that, I want you to switch. Okay, we're going to switch to that YouTube starter branch, and you can see that it's not here. We don't have that Bitfinity whole thing here. So what I want to do is the branch that we have, the wallet providers, the wallets that we have is, we have mainnet, Polygon, Sepolia, and Haddad. So I want to come here and create a unique one. So I'm going to paste this. Please do paste this as well, and make sure you import this chain from Rainbow Kit. Okay, so you can see that it's imported here from Rainbow Kit. And the next thing you want to do is to remove these two chains, okay, and also remove them from here and replace it with this Bitfinity. Okay, so once you do this, you save, and let's run this. Do yarn dev. So this is it before. It doesn't have any Bitfinity stuff available there. So let's refresh this and see how it is now. So this is refreshed, and when I click here, you can see that Bitfinity is available. Let me switch to the network. Switch, and you can see it's working just great. So this is what we wanted to do quickly before we move to the hub of the project. So I'm going to say simply that, added Bitfinity. All right, so I'm going to do that and just publish this branch. So it's online now and people can have access to it. So this is just all there is about, the project structure. So in the next part of this video, we'll start our development. All right, see you next. So when we come into this application, one of the first things we want to do is change this thing, modify this a little bit so that this image will not be overlapping on this text. All right, and to do that, I think this should be what was there before. So to do that, I would like to change this. I would like to add this class. I'll add background to be white, and on this div, okay, and the z index to be 10 on last screen, and the width of this to be 2/3 on last screen and above. So when we save that, we have this, much more, understanding separation. So let's also reduce that to 5 again, and this is not the best setup, but at least it doesn't overlap on this and we can just manage it, and it still also obeys our responsive rules. Okay, so that is the first thing we want to do. So with that out of the line, next thing I want us to do is I want us to come to this place, the root of this project, and create a new folder, call it store. Inside of the store, create a folder called state and another one called actions. Okay, inside of the state, create a file called global states.ts for Typescript, and inside of there we want to export a function, not a function, an object called global state, exactly the same name as well. And this global state is going to be an empty object, but not for long. We want this global state to bear the records that are associated with this global state, which include, we're going to have a record for event, single event. We'll have a record for bearing all the tickets on the platform and for each one of those events, and also a record for keeping track of the status of a ticket model. That model that you use in specifying how many number of tickets that you want to purchase. Yeah, you're going to take care of it here. So this is the structure that we want to use in addressing, what is it called? We want to use in addressing this global state. So you see, I'm grabbing it from here. Now, I'm going to be enforced to make sure that these data points are represented in here. So what we need to do, can copy these lines of code, paste it here, but you just want to make this a null object, this ticket to be an empty array, and this to just be, a string called scale of 0. All right, so you see that error is gone. So this is all you need to do to create a state. These are the states that we're going to be managing globally, 3 of them in total. Then we need to make an equivalent action. So we want to say global actions.ts. What are global actions? Actions in Redux basically are functions that help to change the value of the state. So it helps you to change this value to anything you want that is an object. It helps you to change this, add things into this array or remove something inside this array. And it helps you to do 100 or 0, whatever thing that you want to specify there. So that is what global state does for you. All right, so this is how it is. And global states, they take in action. They have key value just like the global states as well, but their key is the name of the function, and then their value is a fat arrow function. So you want to do, for example, set, ticket. Okay, set ticket. I'm spelling that correct. Ticket. All right, is a fat arrow function. Remember. So this set ticket, if functions in the Redux store, they take two parameters, namely the state, okay, and the action. So now the state needs a data type. Everything in TypeScript is statically typed, so you need to specify what exactly you mean by state, and you need to specify what exactly you mean by action. So that is how TypeScript operates. So what we need by state is anything inside this global state, okay, type. And anything that we mean by action is inside this payload action, right? But that's not it. You also need to specify, because the payload action can carry any data type. So for this, we want to say ticket struct, but we know that the ticket is taking an array, so you need to specify that is an array of what? Ticket struct. So this will make it, be the best way of doing it and give you no error. All right. So in our say state dot, we're talking about the ticket. I want to assign it what we're getting from this action dot the payload that is coming from inside the action. That is what we are using to set up this ticket. So after that, you also want to set up the event. So event singular. So you do set event. An event is going to take a state and an action, but this is going to be an event struct. Event struct. All right, that is what you're adding here. So you're calling this event and you're passing the payload. But you should also know that an event could be null. So you need to inform the store that it can also be null. All right, so that it will not give you error when you're storing, saving, setting, dispatching an action. Okay. So lastly, you need another one called set ticket modal. We only have one of these modal here, so we can say ticket modal here, and the payload this time is going to just be a string. Okay, so this is the payload. With this, we've created our actions and states. These actions will be used to modify the value of the states. You can see all the states. I'm just changing them with whatever I have in that payload. Later on, we're going to be using this function. They are not used right now, but later they will be used. Okay, so we're just setting up our store. The next thing we want to do, we want to say global slices. Am I spelling that correctly? Slices.ts. So these global slices, we bundle the global state and the global action. That is what it simply does. So we say it bundles it so that it can be used when I'm configuring the store. These are various parts of the store, but I've not yet configured the store. When I'm configuring the store, I'm going to now bring in this global slice into it. That is how it makes sense. So for now, you want to say export const this called global slice, and then you say create slice. This is because of Redux. This Redux toolkit has this create slice that helps you to create slice. I think it's a little bit different when you're using the barebone Redux, but this is a much more streamlined and better version of Redux. Reduxification. So you need to specify the name of the this slice. We want to just simply call this global. All right. You also want to specify the states that is associated with this slice. So I want to say initial state to be what? This global state. Okay, see where I'm importing it. And then we want to specify that the reducer, which has basically the function, okay, the functions that we just created, all these actions, okay, that is what it's simply saying. The reducer will be this global actions. All right, so we have all these things, specified. Now we need to export some information. For example, I want to export the default, class, this global slice. Okay, this default object, global slice dot reducer. So I'm exporting this as a default, things. I also want to export the actions themselves. So this reducer, this global slice also has an action. So I want to say something like export const, and I want to call that const, global action. Now, I want to say global action is equal to this global slice, okay, dot actions. All right, so this is what I want to specify. But the problem here is that this global action is already imported, so the name is conflicting with this one that I'm trying to recreate. So I can't use this name like this. I have to give this one an alias. If I say global action as well and just change this to uppercase, then that is what I use here. This just resolves the entire thing. Now to keep things consistent, I would like to just simply do the same here as this, and make sure that that is what I'm using here. So you see this. So we save that and we are done with our slice. That is just all you take. You have bundled this thing together as a slice. Now, the store will then receive this slice. You can add as many slices as you want inside the store. So let's create a store. To create a store, do index.ts. So this is the main file that we'll be exporting. This is basically the main file that we're exporting. You understand? So you can then list as many slices that you want inside the store. That is how the store Redux is aware of all the slices that you have. All right. So you do that by saying export a const store called store, a constant called store, and you say configure store. All right, this is coming from Redux Toolkit as well. And what do you want? You want the reducer. The reducer in this case now are all the slices. So, and the slices we want to give them a specific name. So we want to say state, global states. That is what we're calling them. All right, and the global state is going to have this global slice as it. So you can decide to call this global slice. You can decide to call it global state, whatever you want to name it. But for the sake of consistency, like I've used in different, in previous tutorials, I would like to keep this like this. All right, so I'm going to save this now. And I want to show you something. When you come here and, when you come here and check this Redux Toolkit, to check if there is any Redux. There is no Redux here, so it can't detect any Redux in our application. So because we've not wrapped it around, we need to wrap it around, and how you wrap it around is by coming to these pages. Okay, now to wrap this thing, to wrap Redux around this and be able to have it in our application, inside here, let me close this. Okay, I'm going to wrap this entire thing around Redux. How we do that, we use this component called provider, not providers, but provider, and it comes from React Redux, like you can see right now. So I'm going to import it. You see this? And then just simply move this into that. It's giving me a red flag right now because it needs a property called store, and you have to pass in the store configuration that you've created. You see, as I've added it, it gets imported here. So this is the store configuration, and I've added it in here. So now our application is aware of Redux. Okay, you see it's going to refresh, and when I check this Redux at the bottom, you can see that we have Redux here. The event, the ticket modal, all of those things are part of Redux now. Our application is set for some integration. So in the next part of this video, I'm going to start, integrating. I will start bridging first. I will bridge the data we're reading from the chain or from the back end. It doesn't matter if it's from the blockchain, whatever place that this data are being pulled from. I'm going to first put it in Redux before we make it available in the view. Reason being that when we make change, want that change to reflect at real time, because that change will also affect Redux. So there is a science behind what I'm talking about. There is a logic, and you're going to see how the logic interplay as we move forward into this application. So let's add up that Redux. Okay, so we're only going to need that bridging in a couple of places. I'm going to close out from there. So where we need it is precisely in this page, this event page, this single event here. So this is where I'm going to need it. Okay, I'm not going to have to bridge a lot of things in this particular build, but here it's important. I'm going to have to create some variable constant called dispatch. Okay, and I'll say you should use dispatch. This is coming from React Redux. You can see that. Okay, I also need I'll need to gain access to those data that is in the blockchain, that is in the Redux. So I want to call this use selector. Okay, it's coming from the same place. Now I'm going to target this state. You know that we're using that root struct for now, root state, sorry, that is coming from our interface, types, and then we can call this state dot global state. So this right here will give us access to all the data that are stored here, this event, ticket, and all of that. So for now, you can see that we have an alias called event, okay, and we have an alias here called ticket that we are using for this place. This is great so far, but we will replace this thing very soon. So for example, this data that is coming, this data and this one, want to store it in the store first. You use this effect. We're using this effect to do this. So okay. So use effect right there, and then you want to dispatch a function called. Remember, we need another function an action to dispatch a function. An action is responsible for changing the value of a data point in our state in our store. Okay, so we say equal to global actions. The global action is the one coming from global slice. All right, so I want to set the event, set event. Okay, in this set event, I want to dispatch this action called set event, and I want to pass this event data inside of it. You see that? So this is what I'm doing. So it cannot find it because we're giving it that alias called event, but I'm going to remove that soon. So I'm removing this now. Then I'm going to, you see, but now this place is complaining because it doesn't have access to that event. So I'm going to get it from the store instead because I just finished setting it up from here. You get this? So you see that all those errors are also resolved immediately. This is just fantastic. So now you want to make this a dependency here. Okay, you want to make this also a dependency here, and this event data. So these things are going to be the dependencies here. And not only this, we also have ticket data, remember. So I'm going to grab this. I will do set tickets. Okay, so in setting tickets, I'll pass this here, and I'll pass this ticket data here. But of course, it's going to complaining because it cannot find this thing called ticket data. Yeah, it's complaining that it can't find it. All I need to do is to remove this alias, and this becomes the original name here. But in doing so, it's going to introduce another error here. If you check here, you see, because they are using tickets. Okay, so now all we need to do to resolve that, we're going to just say ticket. Okay, so ticket will resolve this error here. You see, it's gone. So at this point, you just need to add, ticket data as one of the dependency, and this set ticket as one of the items that we're putting in our dependencies. So we save that, and if I come to a single event, you can see that it's loading properly, like nothing happened. Okay, but something happened. What happened is that we just brought in between the interface and the back end, we just brought Redux in between, so that this is served into Redux, and then Redux displays it in our interface there. That makes a huge difference if you don't understand it, but it does really make a lot of difference. So with that done, I think that is the only place we need to bridge for this tutorial, but if there is any usage as we go, we're going to implement it. Now we want to jump into the part where we start coding the smart contract, developing the smart contract, testing it, and all of that. So I'm going to see you there in the next part of this video. All right, it is time for us to develop the smart contract. I would like to first commit this. I'll say reduxified the pages. Okay, so reduxified pages. All right, we can go with that one. Okay, so now we can create a contract folder. So this folder is going to hold our smart contract. So let's do contract at the root of the project, please, at the root of the project. And then you create a file, call it Dapp event x. So, okay. I really don't know the inspiration behind this X. I guess it could be Elon Musk's X platform that is inspiring me to use XXX, across the 4 modules. All right, so this is a representation of the license for this smart contract and the range of compilers that are qualified to compile this code, okay? And we're going to need some packages such as from OpenZeppelin, Ownable for managing the owners, okay, and counters for keeping track of numbers, that are essential to us, ERC721 token for giving people some free NFTs, reentrancy guard to prevent, double execution. That is, insidious double execution. So that is basically what reentrancy guard, prevents. So this is what you need to do. Specify the contract name, and this is the contract name. It's inheriting from Ownable, reentrancy guard, and ERC721. So these are the items that you need to put in there. The reason why you're getting this warning is because we have not instantiated, this ERC721 token in our constructor. So we'll get to that point. All right. So we'll need to create. We're using this counter right now to say that this counters.counter, we want to use it, for counter. So whatever we're using counter.counter, we are establishing a type of data that basically what it does is to convert a variable to a kind of a class that has the ability to increase, decrease, that is methods to increase or decrease, and properties to display the current, status of that number. So let me not speak too much. I will see how it is being used, in action. So right now, this counter, we're declaring it as this will keep track of the total number of events, not the value itself, but just number. Okay, this will keep track of the total number of tokens that we have distributed, like NFTs that we've given out through this payout function, and then it being minted. Okay, so we want to keep track of that. So one of the things you want to take note of is this event struct. This is a structure of how the event is going to be, and it's already it's inspired by this Typescript interface. Basically, we are doing an equivalent of Typescript interface into Solidity. You understand? So this is Solidity. The both of them are statically typed. Okay, so that's why they have to follow all these structures and all of that to prevent errors and that. So that is the reason. So Solidity has borrow some lift from this Typescript way of doing things. All right. So at this point, an event has an ID, a title, image URL, description, owner, sales. Sales basically are the number of times that ticket has been purchased. Okay. sales. Okay, ticket cost, this is how much it costs. This is how much the ticket costs. Capacity is how many people we are taking. All right, seats keep track of how many people have purchased this ticket. Okay, and we have start at, end at, which are the times that this event is going to start and when it is ending. All right, so the timestamp is when it was created. Deleted, paid out, these are all Boolean. It's used to keep track whether this event has been deleted, whether this event has been paid out, whether this event has been refunded, whether this event has been minted. Refunded in a case where, you deleted that payout, you deleted that event before the date when, before the date where this event is supposed to be, it's supposed to take place, you deleted it. What happens is that whole money that you rounded up from that event will be returned back to, the owners of that particular, the owners of the people that bought the ticket. Minted is when payout has been executed. A minting situation is also going to happen, which will result in this Boolean value being toggled to true. So we're going to also need another structure called ticket struct. All right, ticket struct. So ticket struct, you have ID, event ID, owner, ticket cost, timestamp, refunded, and minted. Okay, so these are the data that a ticket structure is going to hold. And there are some things like we need information such as the balance. This is like the amount of money that is available in our platform, okay? And this is the service percent. The service percent, basically is how much we're charging for every event that is paid out, okay? For every event that is paid out, how much we're charging, that is the percentage. It's more like a tax, or a fee that we'll charge because this is our platform. All right, so we then gonna have this mapping. Okay, in this mapping, we are doing event struct. Okay, which is event here. So event struct, how does it go? All the events in this platform, their object is derived from this event structure. Okay, so for every event ID, we're going to save its details there. So this is the mapping holding all those information. Okay, and here for every event ID, we're going to hold all of its tickets, not a single ticket, but all of the ticket that is associated with that particular event. All right, we'll put that in that array. And then this event exists is a Boolean key that verifies if an event exists or not. Okay, so we need to define a constructor now. Okay, this constructor is the first function to be executed when this smart contract is deployed on a network. Okay, so you need a constructor, and that constructor, we want this constructor to unsigned integer to be unsigned integer 256, and it should be PCT. Okay, inside of this function, we want the service fee, which is the service percent, to become equal to this PCT here. So we will actually set up the percentage that we want to use. Okay, so this is the percentage that we want to charge the people in the platform. All right, so afterward, you need to call on this ERC 720 token that is above here. Okay, we are grabbing this ERC 720 token, 721, sorry, not 720, that's why. Okay, 720 token. Then you need to instantiate it. Okay, so you want to say it has a name called event X and a symbol called EVX or ETX. Let's call it ETX or event X. Okay, you see that error that was here had also gone. So with this, we are ready to start, creating events, and doing all of those event management stuff. So in the next part of this video, I'm going to show you how we can create this event. Okay, see you then. Okay, so to create the function that helps us to, add event or create new events, we need a function called create event. I'm just going to paste it here. All right, so this is create event function. What we're simply saying here, we're saying function, the name of the function, opening a parameter and saying that we need these, parameters. The title, description, image, they are all strings, and we don't know, the size of the string. So we use memory to just hold it up there because we don't know how long, how large it's going to be. You have, capacity, token, ticket, cost, start at, ends at. This one, you can see their definite size. This is unsigned integer, 256 bits. You understand? So there is a definite size that has been created for this sort of variables in the, in the Solidity. In the EVM, EVM memory, storage, and all those capacities, where data are stored, the storage. Okay, so now these are the items that we need to use in creating an event. Of course, we're going to have to ensure that these data that are supplied, all this data, want to ensure that they are accurate. Okay, that they are what? Accurate. So we provide these things. First of all, ticket. We want to make sure that the ticket cost, how much you want, people to use in purchasing these. You want people to use in purchasing this event, to have purchased a ticket associated with this event. Okay, must be greater than 0. So you cannot add 0. If not, ticket cost must be greater than 0. The same thing goes for capacity. It must be greater than 0 itself. Otherwise, say capacity must be greater than 0. So we're checking for this is a string, okay? So this is not a number, so I have to convert this to a byte. And byte provisions us with the ability to call on a .length method to know the total number of, the size of that byte. If it is 0, that means it's basically an empty title. But if it is greater than 0, that means it has some, that means it has some data inside of it. So we're doing the same for title, image URL, and description. Okay, then this one we're still checking to make sure that the start date is greater than 0, and the end time is actually greater than this start time, because you don't want to backdate when this should end. Okay, so there we go. Now we need to perform this next. Total event dot increment. This is a function that is attached the moment that we declare this total event as a type of, this counters. It's inherited the properties of that, which includes this increment method. Okay, so this increment method is used to increase or decrease the number. So that means if a number is at 0, we are increasing it or decreasing it. That is what increment and decrement means. So we are incrementing this because by default it's at 0. We're incrementing it to 1 because we don't want our code, our number of events to start from 0. Unless we're working with an array, then that makes sense. But for this case, it doesn't make sense to have an ID of 0. Okay, so we're starting with 1. That's why we first incremented. And then we created an object called this event. You see, this event X becomes an object called, event struct. We can't use event because this is a keyword in Solidity. So I'm using that event X to handle all of this. Okay, so now we've created an object called event, which is of a type of this event structure. So I'm going to say this event X dot, it has an ID. I want the ID to be this total event dot current. Current is the current number, the number that is currently has been incremented to. So by default it was 0, but after this line this should now be 1. So the event ID of this is 1, and we have other parameters to fill up here. So we have these parameters. We have the title, which is this one coming from here, the description, image URL, capacity, all of those things. The owner is the caller, which is mhd.sender. We have timestamp as well, but let me give you a little bit of a synopsis of this timestamp. So this is how we're supposed to call this block.timestamp. Okay, calling it like this would have been okay in some situations. So, but since that, when you come here in JavaScript, when you do date.now, you see that there are, 13 digits of this. I mean, if I check it out again, say .toString, and then you call on the length method, you see that it's 13 digits, number. But the one that is, this one right here that is being gotten from the EVM itself is 10 digits, which is not enough. Okay, 10 digits isn't enough to match what we're operating at in the front end. So I want to make a modification. This is what I do. I made a modification to improve the output here. So the current time is this block.timestamp multiplied by 1000, and then you add 1000 to read. This will cause the number of block, the value that is returned to increase to basically 13. Okay, to increase to 13, and then I can then use this, in replacement here. So this is a very important step. All right. So after we've done this, the next thing I want to do, I want to declare that this event exists. Okay. So we say event exists, which is a mapping that we described here, passing the event ID and mark it as true. Okay. So I'm passing the event ID, this event x.id, and then saying that it's true. Okay. So now it exists. All right. And then I must, put this event, this event now, must put it inside this mapping called events. So say events, and then I target it with this event x.id. Okay, and then you say it should be this event x. Okay, so with this right now, you have been successful in creating a new event. So in the next part of this tutorial, I'm going to show you how you can, update and delete events, get events, and all of those things. So I'm going to see you in the next part of this video. All right, so let's create that update event. So it's going to be very close to what create event looks like. So that's why I'm going to duplicate this, change this to update event, open up this parameter. We're going to add one extra parameter. Okay, I'll call it ID. So this will be the event ID. Okay, so and you want to ensure that that event is available. So you're requiring that event exists. You pass this event ID. If it doesn't exist, you want to say event not found. Okay, so that is quite important. Now the next thing after here is to rewrite the existing one. So what I will simply do is we can decide to grab this, like grab the information, So let me remove this. We don't need to upgrade this. We don't need this either. We don't need the things that we don't need. We're going to remove them from here. Okay, we definitely don't need this. So now I'm going to say that this instantiate this variable with the real one. So I will say event. Okay, grab it by the event ID. So this will grab us that event, and then we can update all of this inside here. Okay, so I think that is it. So with this setup, you'll be able to update an existing event. Simple, straightforward, no hassle. Okay, so after this particular change, we want to delete an event. So we can see, oh boy, I kind of did this. Okay, so I'm going to shift this upward. Okay, so shift this upward. Okay, so, and then I'm going to update this. Change this update event to delete event. So I'm going to remove the rest of these variables because we don't need them for deleting an existing event. And there's something I missed out in this, that in updating an event, we want to make sure that whomever is trying to update an event is the owner of that event. So I'm going to say target that event and then call the .owner method. I want to make sure that msg.sender is the same as it. Okay, so otherwise say unauthorized entity. Okay, so we can do this, copy this line, then come here, replace it here. So we have that going on for us. And the only thing you just want to do, you don't want to do too much. So I'm going to remove all this. Okay, so I'm going to target this event by this event ID, and I'm going to call on the deleted status and assign it to be true. So this will delete an event. And again, there are some situations where an abuse come into the platform. Like let's say for example, there is an event that were perpetrated by scammers on our platform, and if we don't have access to delete such event and refund the people that own that event their money, then there is chances that that our platform will not be able to defend people from these scammers. So that is one of the reasons why we're going to do this way. We're going to add an extra agent that we perform some deletion. So say msg.sender sender, if we want to say all here, if this caller, if the caller is the owner or the caller is like the platform owner with this is enabled, this is giving us because of this ownable class. So this owner will be marked as whomever deployed the smart contract. So either the event owner or the platform itself can delete an event, just to prevent some illegal stuff going on here and to make things fair for everyone. All right, so you can see require. There are other things that we want to ensure that is on point. Before you can delete an event, we want to make sure that that event is not already paid out. If an event is paid out, then you should not be able to delete it just for reasons such as we're going to refund people when you delete an event. So if that event is already paid out, then there is no use trying to delete that event. So that's why we're adding this piece of requirement here. I want to say event already paid out. So if it's paid out, it is paid out. It must not already be refunded, because if it is refunded, so we want to say refunded. So, and if it is deleted, so it cannot be it cannot be refunded without it being deleted. So basically, this is enough. You understand? There's one more step which will perform refund. Okay, we will do this later once we start collecting some ticket, once we start giving people their tickets. Okay, so with this, I've shown you how to update an event and how to delete an event. All right, so in the next part of this tutorial, I will show you how to read information about an event. There are many things we need to read about event. Then we can start designing the ability to buy tickets. You get it? All right, see you in the next part of this video. So now let's get all the events that are associated with this platform. So all events that are valid, which will include events that have not been deleted, okay, that have not been deleted. So those events, we're going to list them all out. So now this is a parameter. It doesn't have any parameter. This get events. It's public, is view, so it's going to return information. It's going to just display information. It's not a write function. Okay, it returns data that of this type of event struct, but an array of it, and I'm giving it an alias of these events because I'm going to use that is what I'm targeting to return, this variable. So we're going to manipulate it all before we return it. So by doing this, I don't need to write a return keyword here anymore, but this particular function just knows to return this at the end of this, because at the end of this function, because it's been specified here that returns this data type, and we putting it in memory. The only reason why we can specify to return a certain thing is maybe we don't put this like that, then we can return something. So that is one of the things I want to inform you. All right, so the first thing I want you to know is that we want to create a variable called available. Available will keep track of all the available events. That means events that have not been deleted. So we want to keep count of those events. And how we keep count of it is by using a for loop. All right, a for loop. And the for loop is going to start from 1 because we want to loop through the mappings, and the mappings start from the index of 1 because that is what we specified, when creating, that event. So we started our loop from 1. I'm going to just make sure that this retains the same data type, and then we want to do this until I is less than or equal to, because since we're starting from 1, we want to make sure that it aligns with the total events dot current. Okay, so now we're going to loop through all the events using this parameter I just suggested. Now, but again, you want to make sure that you see we have this thing called events, right? And you want to pass that I here for every event that you're checking. You want to check this deleted status. You want to make sure that the event that you're checking for is not deleted. So if it's not deleted, then it should say available, increase it by 1. Since we only have one line of code here, we can just put it in one line here. So available will be incremented for any event that has not been deleted. So that is a criteria. So now, once we have all these things, we need to redefine the structure of this array. Not just the structure, but we need to redefine, the size of this array. We want to say that this size of this array is equal to the exact available size, so that it is required this way for you to do it this way. This is the best way I've found out doing these things. Okay, I've learned quite a lot from coding this Solidity stuff, and this is what works for me. All right, that's why I'm doing it this way. So first of all, the first looping is to find out what is the size of this array. Okay, which I can say this event, okay, I want to declare it as a new event struct array, okay, and I'm going to give it a size. The size is going to be based on that available size. So with this, you've defined the size of the array, straightforward. Next, you want to define, we want to run this whole thing again. We're going to run this whole thing again, but this time I want to define this to be index, okay? There's a reason behind this. And also, so basically this is the same thing that you're doing, all right? Now, we want to be pushing, we want to push or want to, put into this array any event that meets this criteria. And how we do it is by saying this event, and then you target this index. The index by default is going to start from, 0. So we say index, this starts from 0, and we'll say that events, basically we want to say this event like that. So with that little piece of code, all the events that match this criteria will be added into this list, which will be exactly the same thing as this one, this criteria, because everything has been well measured and set. Okay, for this thing not to hold water, you need to be incrementing this so that it will not be adding it exactly to the same index. So on every addition, you want to increment this by 1 at the end. So this way, the first time is going to be 0, but immediately that it is 0, this plus plus will make sure that it's incremented by 1. So it's going to become the next index the next time that this iterates again. All right, so with this, remember what I told you, that I don't need to do return event again because by the specification of this little thing event here, it's it relieves me from doing this. If I do this right now, it's just a redundant effect. So that's why I don't add it, okay? So with this, I've been able to get events. Okay, I don't want to only get all the events. I also want to get like my personal event, an event that belongs to a user, or the event that a user created. So we can say get my event, okay? And everything is going to be the same, but now the condition has to change a little bit, and we can change this condition. I'm going to highlight the both of them. I'll say and, the event, dot owner is equal to this caller dot sender. Okay, so if you run it this way, then definitely all the events that are going to be returned be based on whether they are the senders, whether it belongs to this sender, and if it has not been deleted. Okay, so those are the two criteria. Otherwise, there's one more thing I want to do, one function to get us a single event, okay, because it's not all the time that we want to get all the events. So I say get single event. See, you can't say get event as in singular, get event like this. This is an inbuilt function, it's going to conflict. You understand? So don't call it this way, call it single event. I've tested it before and I had to be marveled about what Solidity did not tell me. All right, so use this get single event. There's a reason why I'm calling it this way. And this is going to require that you pass in an unsigned integer, okay, of the event ID that you're looking for, and we want to return an event, a single event, so it's not an array. I'm going to remove this too. So this is what we're returning. So what you simply want to do is to say return this. All right, and you pass the event ID inside of that. So with this, you'll be able to return a single data point of an event. So these are all the read and write operations that is, it consigns events. So in the next part of this video, I'm going to show you how to buy tickets, create ticket, and all of those things, refund ticket, and all that, payout as well. So see you in the next part of this video. Now, to buy a ticket, you need to write this function. So the name of the function is buy ticket, as simple as this, buy tickets. And for performance reason, because there's a lot of for loop going on here, and also we're going to keep the maximum number of tickets that a person can buy at once to 3. We don't want to create something that, of course, this person can purchase as many times, but this just for that we're doing a for loop to buy all those tickets. So instead, let's keep it at 3 maximum, so that it will help in the computational time for this thing to be processed and done. All right, so we're going to keep the maximum at 3 events at a go. So the first thing we want to do is to, of course, always check that the event exists. So this will help us to make sure that what we're planning on getting is a real event, and we want to make sure that the number of tickets is definitely greater than 0, okay, and greater than 0, and this same number of tickets is less than, or is less than, this is greater than 0, is less than or equal to 3. So we want to keep it at a maximum of 3. Number of tickets must be within, we can say something like 1 to 3. Okay, so we have those there, so that will make sure that we have the right range of ticket that people are purchasing, and keep the computational time a lot friendlier. And you want to make sure that there's a critical thing here. First, let me show you this requirement. There's some critical stuff that you need to take note of. We want to make sure that MSG does value, because this is a payable function, okay? You're sending money to this contract, and the money you're sending, we want to ensure that this money is greater than or equal to, whenever I multiply the number of tickets, okay, if I multiply it by the event cost. So the event cost, the ticket cost, if I should bring it here. So if I say, ticket cost. So I'm multiplying the number of tickets by the ticket cost. And so I'm using that to check if the money you're sending me, if I multiply it by the number of tickets, it's equal to what the ticket cost is. But if that doesn't work out, I want to say insufficient amount. Okay, so that is one of the critical check we want to do. We want to do another critical check. We want to see that, because you're booking, we want to know how many space we have left, and if the number of tickets that you're trying to buy is still valid. Like we don't want to give more than we have capacity for. So we want to always check our capacity before we give you that space. So we're saying that we want to check for the number of seats that are remaining. So seats, if I add this number of tickets to it that you're trying to purchase, we want to see if it's still less than or equal to the event capacity. That an event has number of people that can come in. So the maximum number of people that can come in. So I want to check if it's equal, greater than or less than or equal to the number of the capacity that we have. So if this does not match what we're looking for, then I want to respond by saying out of seating capacity. You get this? So out of seating capacity. Okay, so those are the critical checks that I am talking about. So now, if all these criteria are checked out, we want to perform a for loop now. This for loop starting from 0 until it's less than the number of tickets that we want to purchase. So this is it. Now I'm going to purchase each one of them. I'll first create an instance of a ticket, using this ticket struct. So say memory, call this ticket. Okay, so we created that. Now for ticket, dot ID, I want the ID of a ticket to be, remember here that this ticket holds all the ticket for a specific event. So I'm going to target the event that is related to this one I'm creating, and then, check the length, how many tickets do we have yet in that place. So we want to say ticket, okay, dot, not, hold on, say ticket, okay, call on this ticket, and then you pass in the event ID, and then you say dot length, okay. Am I sure if I'm getting it? This is ticket, okay, ticket, and this is single ticket here. So hope we're not making any mistake here. How many times do we have this ticket? Exactly. So we only have it 2 times, so I guess we're correct. So dot length, okay, so this will get us the exact number, the ticket ID. So the ID, we want it to be exactly the same as the index space, that is the location of that ticket in that array. So that's why we're giving it this ID system. All right, so it's just a very intelligent way of putting it together. So you have this another one called ticket dot event ID. So the event ID must be the same as this event ID that you're passing. Okay, you want the ticket dot owner to be the current caller, msg.sender. Okay, and you want the cost of this ticket, say ticket dot ticket cost, to be the same as this ticket cost here, this one. Okay, and you want the ticket timestamp, ticket dot timestamp, to be equal to this current timestamp here. And lastly, you want to push into this ticket array. So you want to say ticket dot push, and then you push in this ticket singular. Okay, so this we create all the number of the tickets according to the number that you specified. Remember, I said the range is 1 to 3. So it can be maximum of 3 tickets that you can purchase at a time. So now that we have that whole thing going on, so I want to say events, okay, dot event ID. You want to target the number of seats, and you want to increment it by the number of tickets that they purchase. So the seats increase. That means that we're running. That this event, that specific event, is running out of capacity, and then you want to increase the balance. msg.sender want to keep track of, no, not the sender, the value. Okay, so you want to increase it according to all, the number of the money that you have. So all this money that is being, you want to just keep track of it in the general balance. So that is what we're doing in here. Okay, so this is how you buy a ticket. All right, so in the next part of this video, I want to show you how you can refund a ticket. You can refund a ticket and so on. So but before we jump into that, I just want to show you how you can get all the tickets that belongs to a specific event. So if I want to get all the tickets that belongs to a specific event, I can simply do that with this same method that I've established here before. So if you come here, paste this is get single event. I'll say get tickets. Okay, passing the ticket ID, but what it's going to return is a ticket struct, but an array of it. Okay, an array of ticket structure. And what I just need to do is to come to, just like what I did here, I just need to come to, where's that ticket? This ticket here. I just want to return this. So I'm returning this. And that is just all you need to do about getting a single ticket. So you use this to create tickets. You use this to what? Read or get tickets. That's just read and write operation there. So let's do the rest of the coding in the next part of this video. Before we proceed to other aspects of this ticket purchase and all that, we want to write a function called refund ticket. This is supposed to be part of this delete, because whenever we delete a ticket, then we want to refund all those people that have that ticket, that bought that specific ticket for that event. So we want to call this refund ticket. The refund ticket is going to be an internal function, so it's not going to be callable outside of the smart contract. So it's an internal function, and it's going to return Boolean true or false once it is executed. It takes in an ID of the ticket of the event that you are planning on refunding. Okay, so we need a for loop. Then this for loop is going to go through this, starting from 0 down to the length of, that is all the people that are inside that ticket. So we want to pass this event ID. I want to say dot length. Okay, so it's going to go through all the people that are inside this specific event, the people that purchase ticket for this specific event. And we're going to say that the ticket of this unique individual, I want to say dot refunded to be what? True. I will target that to true first. And then I will say that the balance, the general balance that we have in this platform, I want to reduce it, by the ticket, okay, dot this event ID, okay, and and then I pass that I, of course, and that ticket cost. So I'm going to remove each one of those ticket costs until it's done. I'm doing it in an array because I don't have time here to come and be recalculating and know how much in total that I want to delete at once. So this is the best place to do it, okay? And then we want to, pay these people their money, okay? This is not paying them their money. This is just doing some balance bookkeeping, okay? So now there's a function I normally use. It's called pay-to, as is an internal function, all right? It's a low-level function that takes in the address of whomever you want to send money to and the amount that you want to send, and performs that payment. It wraps it around a payable clause. This ensures that this address can receive money. So I perform a call and send that money to that particular person. This returns a value. So we are requiring that it has that success value, okay? If it does, then it is completed. But if it doesn't, then it failed. And that's one of the reasons why we're doing it, so that it will revert the entire procedure that had happened there. So the entire procedure, whatever things that you're doing, because it is required, if any requirement fails, it's going to revert all the whole computation that has been performed there. So I will say pay to, okay, and then I'm going to pass in the owner of this ticket. So this particular ticket right now, I want to pass in the owner dot owner. So this is the person that purchased the ticket, and I want to pass in the ticket cost. So this is the amount that this person used in purchasing this ticket. And then at the end, that we make for all of the things that we need to do there. At the end, we want to say that this unique event, okay, this unique event, if I say event, all right, dot event ID, and then you want to call on the refunded to be what? True. So for that whole event, we've refunded everyone their money. And then lastly, you have to return true, because if you look here, this thing is still indicating that you've not returned anything. Okay, so you want to say return, true, as a way of indicating that, you have done all the things that you required and this thing was successful. Okay, so now we'll come to this place and we want to then perform a a refund. So we want to say refund, refund ticket. So we want to pass in this. Okay, knowing that knowing that this particular function, this delete function, it carries the ability to send people money. So you don't want people, executing this multiple, trying to attack it using reentrancy method. Okay, you want to say non-reentrant, reentrant. Okay, so by doing this, you prevent that double execution in one go, and you want to make sure that this is put inside a requirement. So we are requiring that this is refunded, otherwise say, I want it to say something. So what do we want it to say? Event failed to refund. Event failed to refund. All right, so this is good. This is good. So this is how you perform a refund, for this particular project. And in the next part of this video, we will do the necessary things such as, payout function, maintain function, and all of that. So I will see you in the next part of this video. Okay, so let's add those remaining functions. So this function we want to add is called payout. So it will be responsible for, giving the event, host, their specific amount of money. Okay, so however money they've made out from the sales of all the tickets, whenever they run this function, they will receive all that money, into their wallet. And at the same time, that will mint, our freebie, our free NFTs to all the participants that purchased that ticket. So that's one of the things we're sponsoring. So that is that ERC 720, aspect of this course. So as usual, before you can pay out, we must ensure that this exists. Okay, this thing called this event actually exists. Okay, once you verify that event exists, you want to ensure that event is not already paid out. Like you can see how we do that here. We ensure that events are not already paid out before you can delete, any event. So you want to ensure that no event is paid out. So, and the next thing afterward, you want to ensure that the current time is greater than the end time. Otherwise, anybody can pay out at any time. We don't want people to be able to pay out when they are not supposed to. And that's why we're using this code. Current time must be greater than the time that it ends. So the ends at. Otherwise, you should say still ongoing. So the event does not pay out until the event ends. All right. So, and we must disable this, when we are testing, because this is not going to allow us to test out this, waiting till the time ends. You understand? So another requirement there is that the people that are permitted to pay out an event is either the owner of that event or the platform, because of certain reasons, such as it's much, since this particular each payer does not only affect them. If it only affects them, then whatever, if they want their money to be stuck on the chain, let's say they lost access to their private key or whatsoever, then it will not affect anybody but them. But in a case where one person has a problem with their account or is unresponsive, then we can come in. So that's the only place that we can come in. All right, so we want to say that this event, the owner must be the scholar or the caller must be the owner of the platform, otherwise say unauthorized entity. All right, we lastly will then mint that. So we say we actually mint some free NFTs to them. All right, after we mint that, we perform the payout as well in this step. So of course, you want to get the revenue. How much did you make out of this event? So we want to know that. So we're targeting the event and we're calling on the ticket cost, multiply it by the event, dot seats. The seats are actually the number of people that attended that event. It's different from the capacity. We can't use the capacity because it may not be everyone, that event may not be filled out, okay? So we use this to calculate how much, everyone makes at the end of the day. And, okay, and we also need another one called fee percent. So this fee percent, or we just go by fee, we use the revenue and multiply it by the service percent. So we say revenue multiplied by the service percent, which is above there. The service percent, once we multiply it, then we can divide it by 100. This gives you, the exact amount that goes for what? The fee, the platform charges, okay? So at this point, we can call on this pay to function so that we'll pay the relevant people. Okay, first we want to pay the event owner, which is this event owner. And how much are we paying the event owner? We want to pay the event owner the revenue minus the fee. Okay, so this is what the event owner gets, and what we get is, which is the platform owner. What the platform owner gets is the fee. This is what the platform owner gets. So afterward, then we want to mark this event. Okay, we want to mark this event dot paid out to be true. So the event has been successfully paid out, and we'll minus, that revenue from the, from a balance. And there we have it. So with this payout will happen, there's one step here that we haven't done, which we're about to do. But with this, we effectively, dispatch the finances that was made out of any event that was hosted on our platform. Okay, so the next step is to create a function called mint ticket. Okay, mint ticket. Mint ticket, of course, is going to take the event ID. All right, it's going to be public. No, not public. Internal. Okay, this is not going to be called by any other person. So it returns Boolean value on successful execution. So we're using a for loop here. Okay, this for loop starts from 0 and it will loop through every member in that event. I think it is something, similar to refunding a ticket. So we're going through every ticket holder. We're going to every ticket holder for this particular event. And now we are going to, call on, that we had this thing called total tokens before. We have not used it ever. So it's time for us to use it now. We want to say this total tokens dot increment. So this increment function will increase the total number of, of token IDs. Okay. So we want our token IDs to start from 1. So that's why we always increment first before we call on the current. And then you want to target this. This is this particular ticket, or the ticket that this event does have, and this is the specific ticket that belongs to this current user. So we want to say .minted is true. So this guy true. So we want to say we've minted this person's, on, and then we actually perform the minting. To perform the minting, we use the ERC7, token, token function, ERC721 token function called _mint. It came as a result of us using this and hooking it up to our, project. So we now have an inherited, function called mint. This mint takes the ticket owner. Okay, so it takes the ticket owner. We can call this dot owner, and then it takes the current token ID. So the current token ID is something like, because we're making it global, so the token ID is not specific to only the people in that ticket. Is in that list. It's specific to everyone that has been given an ID that have minted a token on our platform. So I want to say total tokens dot current. So this gets us the current ID for that unique for this unique iteration. All right. So at here it's after I run this code, it becomes 1. So the current here is 1, and on the next iteration becomes 2, 3, and so on. So at the end, you want to say that event, this particular event, you want to call on the minted key and say it's now true because you've minted, and you can return true as well, indicating that that this operation, this has been completed successfully. Now you want to put this as a requirement here. So you say require first that minting be done. I pass the event ID. Otherwise says event failed to mint. You understand? So this will ensure that minting happens even before you start, paying out the owners of the platform and the owners of that event, and then balancing of everything. So this is how we code our smart contract. At this point, we're done with all the functionalities that we need in our smart contract. So in the next part of this video, I'll start showing you how to test this smart contract. And for people that are on Dapp Mentors Academy, this will be the part where you watch how I test the smart contract and other adjustments that I may make in the smart contract because of maybe I found a better thing that I needed to do, or so. Okay, that needs to be integrated there as well. So I'll see you in the next part of this video. So now, before we be able to move on, see, I'm showing this part because this is for those people that are watching from YouTube. Okay, and there are some things that have been done here, such as the testing of the smart contract. You can see these are the test scripts for this smart contract. And open that, and all of these, they are all shrinking. But this is a script that we developed, and this is another script for deployment, and another script for seeding of smart contract. All these things were coded, and you can have access to them, watch them for free on Dapp Mentors Academy. You understand? So you need to jump into that place and watch that part. You can pause this one and go and watch it. It features the test-driven development approach of this smart contract. So we did some tests, we did some modification, changes, and all of that. So I will highly recommend that you visit that place and watch it, okay, before you jumping back into the next step that we're about to do. But if you don't want to go through all that route, you just want to continue on, you don't care about the smart contract testing, validation, and retuning, and even the seeding of the smart contract, then you can come to my repository, GitHub, find my repository, and then look at this Dapp events, this project here. You make sure you switch to the YouTube starter branch and go to the contract folder. Okay, so inside this smart contract, this is the most completed version of it. So this is the most, tuned up and well, the perfected version of it. So you should get this way bring it into the same page, that we are. And also you should get this folder and its content, this test and its content, and also this script and its content. Make sure that you have it, part of your project here. Understand? So you just paste, you can replace the the one that you have with this new one, so you need to do that. So once you do that, then we need to spin up the blockchain server, which is hard hat in this case, because we need to have a place where our smart contract will live. So say yarn hard hat, node, and this will spin up the blockchain server. You can see it on. Now you use another terminal and push in the smart contract, deploy it. So you say yarn hard hat run script. So we use scripts to perform to execute some activities, on a smart contract. You understand? So for example, we use this to deploy, this smart contract into the network. You say yarn hard hat run script /deploy.js. You run that, and you see that smart contract is deployed. So you also need to run this seed. The seed script basically just adds some dummy data into that network. So these data are generated and loaded into the network, so we won't have to start from scratch. So I'm also going to run this, but just changing this seed.js. So you run that, and boom. Okay, so we have all the items executed and run. So with this now, we can jump into the other part without getting confused about what I did or what I did not do. So this is what I just wanted to show you in this little part. So alright, it's time for us to do some integration. So the integration we're talking about is literally making use of all those functions we wrote in our smart contract. So the first thing I want you to do is create a new file called blockchain.tsx, Typescript extension, and this is what we're going to be writing all the intermediary functions that communicate with our smart contracts, unique functions. So we're going to need some default stuff. For example, we're going to need this ethers.js from ethers. We're going to need this contract address, and we're also going to need this ABI. So this ABI is correct. So the link, these are all the ABI that makes for this smart contract that we created. This is the contract address, and this is ethers.js. So we have those things available. Now I need two functions. We're going to be using these two functions in the course of this project. The course of this script. So what they do, they convert value from ethers and to ethers, you understand? And the ethers we're talking about, is the smaller denomination of it called we, you understand? So we need these two variables, one for storing the state of the injected Web3 provider, and then this one is for holding the result of a transaction that has been confirmed, on the chain. So we have something to do. We want to test if this window is loaded. Okay, so we're testing if we have windows, type of windows is not equal to undefined. That means it is defined. Okay, we want this Ethereum, variable. Want to give it this window dot Ethereum. Okay, so this we just store this thing in this variable called Ethereum. So we're grabbing this from the windows and just storing it right there. So that is what we're doing. Okay, so with that said, we need to create a function. This function is called get Ethereum contract. Get Ethereum contract. And what get Ethereum contract does is to fetch the instance of the smart contract either through the browser, injected browser provider, or injected Web3 provider, which is the browser-based, provision, or using the RPC, method. So this function is going to be intelligent and selective. So if I'm calling a function from the server, from the back end, then it's going to use the RPC method. But if I'm calling it from the front end, that is like from the browser, then it's going to use the browser-based method. So that is what we're coding in here. And the first way for you to understand if something, it's on the server side or on the, client side, we use this to test. If this works, if we retrieve some account here, that means we have a wallet connection that is active. And if there is a wallet connection that is active, that means our browser-based connection can be utilized in this case. So what we want to do is to check if we have account, we expect that this is going to be an array. So dot length of it, if it is greater than 0, then we want it to do this. Otherwise, it should do something else. So if we found account that is connected to our browser, then we want to use browser-based connection. But if there is no browser support or no wallet connected or in any way, then we want to use the server side, which is the JSON RPC method. That is the grammar here. So the first thing you want to do is to get a provider. So say const provider. This provider is going to be, we want for here is going to be etas dot browser provider. You see what I'm telling you? And now this browser provider, we want to pass the object that is found in our browser, which is this windows.ethereum. This is the object that is found that can be, used, that this can wrap around, this browser provider can wrap around it. So etas, we use this browser provider to wrap around this Ethereum object. So now we can do transaction, signing of transaction, launching of that MetaMask wallet, and all of that programmatically will be handled because of these lines of code that we're writing. So once we get the provider that we want a signer. A signer is someone that is going to authorize a transaction. Okay, in this case, we want the currently connected wallet address to be the one to do that. All right, so how you get a signer is by saying await this provider that we just instantiated get signer, because the provider has information about the signer, the current signer, or the person that is currently connected. All right, and then with these two information, we can use that to, create an instance of the smart contract, get the instance of the smart contract. So you want to say new etas dot contract. So you see that in the past couple of scripts, we have different, method to instantiate, a smart contract. The first method is to deploy and have it instantly. The second method is by using the ABI and the wallet address and also without the sign or anything, so that is the method of contract art, okay? And then lastly, a method called this.contract, which requires a signer and the ABI and the wallet address. Those are the information that it requires. So we call this is supposed to be contract, okay? So we say that this address that we have here, address dot this, okay? I don't know if we can just do this, destructure this, and yeah, we can actually do that. And instead of doing address dot that, we can just pass in the address straightforward. Here we can also destructure it by just saying ABI, okay? And when you do this, you get to the ABI directly. No time for too many, talks. All right, so this is it. We can even call this contract address. Well, let's call it address. Come on, address. Say as. Sorry, on will say as address, and then we can pass it here like this. So when we do this, it leads us back to that same place. So this is what we're using. Okay, so we have this, we have the contract, we pass the address and the ABI, and lastly, but not the least, we also need to pass the signer. All right, so that will help us to create an instance of this smart contract. Now we need to return it, okay, because that is how it can be used elsewhere. So this is one way to get a contract instance. But the second way, which is through the JSON RPC method, you need to make sure that this provider is not browser-based, but what? JSON RPC provider. And we're not passing the Ethereum object, but we want to pass an RPC, so an RPC URL. So if you open this, if you look at this right here, this is the RPC URL for our existing, our existing blockchain, which is the Hadap. You understand? So I'm going to use that to replace this. So we say process.env.dash. Okay, so this will hook up the right RPC URL. You see, I'm not supposed to reveal my environment variable, but just because I want to teach you, like plainly on a slate, so I'm doing that for you, So just know that, and also know that I don't use those accounts. Any accounts that I use for this is strictly for tutorial purposes. Okay, so say const, we have wallet is equal to, you see, the signer, we can't get the signer this way. We have to use a different way to do that. So how you get that is, that on the browser, I can determine which wallet is calling because the wallet address is provided by MetaMask. But if someone is interacting, is calling, is trying to communicate with the blockchain from the back end where there is no wallet provider, then we need to provision another way that communication can still go through with the specific wallet address that we want. But in this case, we want it to be a random wallet address. So that's what we're using to call this. So right here, we're going to create a wallet address, call it wallet, and say it's ethers.wallet.createRandom. Okay, so this creates a random wallet address for you. And then now for you to get a signer, the signer basically will be this wallet address.connect. You connect it to the provider, this provider we have here. So now this signer is valid. So this is the only two changes that we did other than this here. So this is how you legitimately get an instance of a smart contract. So in the next part of this video, I'm going to show you how we can start communicating, interacting using this smart contract instance that we've gotten now. So I'll see you in the next part of this video. So let's create that function called create. It's called const create event. So in order for us to create event, we're going to really do the same thing that like we've been doing before. So let me remove this. So this is a function, right? A synchronous function called create event. What do I want to pass in here? I want to pass in an event, but this event is of a type of event params. Event params is a little bit different from event struct itself. Event struct is loaded with a lot of data coming from the blockchain, but these ones are just parameters that you want to use to validate that the data that you're entering here, they match the correct types. Okay, so that's what the difference is between them. So the first thing I want to do is to check if we have Ethereum provider in the browser. So if we don't have an Ethereum provider, we just want to report an error. Come on, report error. So we're reporting an error, And the error we're saying is simply saying, please, install a browser provider. So this could be MetaMask or Trust Wallet. And we want to return, that this is asynchronous. So we're expecting to return a promise here. Let me show you. We're expecting to return a promise, but this promise is a void promise, okay? So this is what we're expecting to return. So now I want to say that it should return promise.reject. Since this is an async function, I want to reject with a new error. And this error is simply saying browser provider not installed. Browser provider not installed. Okay, so now we'll do a try catch, and if there is any error, we want to report that error and also log out, return a rejection of that error. So, but if everything goes well with it, then what we want to do is to fetch the instance of this contract. So we want to say contracts await get Ethereum contract, this function above here. Great. So now we have an instance of that smart contract. So now we can basically come to where's that script without having to do much. You can just copy this line of code right here. You see that? And paste in here. You don't need this const being there. And you know that this event params has this thing called ticket cost, which a ticket cost is bringing error because it can be a number or a string, but we want to make sure that it's actually a number. So we just say number. Okay, so there you go. There we have it. So this we create, and it will create an event for us and wait out till it's executed, and then we just return a promise that is fulfilled. Promise.resolve with this transaction reference. Okay, so with that, all we need now is to make this event, create event function, an exportable member so that it can be used outside of this place. At this point, we can come to these pages. The pages where I think we should have a place to create. This is a form for creation. So let's look at that form. I hope this is up and running. Let's start up the server. Okay, so let's restart this interface. Could take it. All right, restarted. So now let's go to this create. I want to make sure that we are on hard hat chain because that is where we are. Hard hat chain. I want to disconnect from this guy. I want to be connected with the account that has some ethers, which is this. We can call this. We can rename this basically. You can say call it owner account. Okay, simple like that. So owner account, and let's add event by clicking this add event. Make sure you connect this wallet just for connect it and sign that signature. So you have this here. So you want to create the first event. So we're going to fill up this form soon, but this is the form that we're creating, we're using to do this. Okay, so now let's come back here. This is where we need to hook up that function because this is where this event is coming from. If you watch carefully, you will see that we have a form here that we're collecting all these things from a form, and this is called event params. And if you watch, this is basically a form, and all this information, titles, capacities, ticket costs, image URLs, what have you, start time and end time, all these descriptions, they're all coming from a form. So in order to utilize that form, we've set it up in such a way that when you're submitting this form, it calls this handle submit function. And this handle submit function takes that form event and prevents a default behavior, and checks if, if we have our wallet is connected, because if our wallet is not connected, then it shouldn't, proceed, do this. Now we need to convert all these dates, because the ones that we're getting from this form, they are not pure, integer, so you need to convert them to a timestamp. So we're doing that for start and end time. And then this is the promise that we use with Toastify to perform the addition to the chain. So at this very spot, I want to say, I want to say create event. Okay, we're getting that from the blockchain service. And when you do this, you need to just pass in this event right here. So this event that's coming from this event params, I'm going to say event. Okay, so we'll have event, and then we have then. All right, so we have then here. This is the transaction that is being resolved with, if this is resolved. And you want to do stuff like, we want to first of all log this to the console, call it tx. After logging into the console, we want to resolve with this transaction as well. So you get this. So, but if there is an error, .catch, you want to catch that error and reject with it. So this is what is going on here. So this is what is going to happen. But added to this, we want to push this to the main page. So like, we want to get like, say const router is equal to use router, and then with this you can come here and say that want router dot push, push to the home page once it is done creating. So you get it. So yeah, this reset, you can decide to push to the home page or just reset the form. I think I'll go with resetting the form, because you may not want to, leave that particular page. Maybe you want to add more than one event. So at this point, you can say reset form. Okay, so that will kind of match well. So, and all this data will be reset back to, zeros. So now let's check it out. Okay, I'm going to paste this. This is the name of this title, the title of the event. Okay, and this is the image URL of the event, and we also have capacity. Want it to be 20 capacity and 1.33 ethers. The description should be something like join us, blah blah blah. There's a lot to say and all that, thing that they used to say. Okay, so I'm just gonna get a better image. All right, just a much cleaner image. I think I should get that from Pixabay. So let me get an image of blockchain. So getting an image of blockchain. So we're gonna use that to replace this. See that shows up here. That is how we designed it, that whenever you enter a correct image, it just preview for you here, so that you can see the image that you are entering. So you can click this, we've not entered date. Which day it starts? It starts yesterday. Let's just say it started yesterday, or let's say it starts tomorrow of 12th, and it ends like 19th. Okay, so let's click on submit. Sending approval. I see it's launching the MetaMask wallet now. Waiting on it. Okay, so this is what you charge for transaction. Okay, this is basically $2 for the transaction. Okay, how it goes. So this thing is coming because we've not reset that wallet. Remember the whole crazy thing with MetaMask on a blockchain that you keep restarting, it will have a wrong nonce number. So you want to reset the activity, basically clear all activities, and then you want to perform this again. So you confirm that. You see it's been created, and you see the form was reset. Okay, but it's not yet visible in the home page, which is what we want to do next, because you need to see exactly what we are doing, So let's do that in the next part of this video. All right, so we need to add some functions here that will enable us to retrieve some valuable data from the blockchain. So let's say const get event. You see, I don't need to be writing all these things over and over again. We've already done this in the scripts. If you come to the script here, we have a function called get, events. All right, we just need to modify that function a little bit, but it's the same procedure. We don't need to pass in contract in here, but we can get the contract by accessing the instance of that smart contract to say contract is equal to await get Ethereum contract. So you see that. Next, you want to insist that this returns a promise, and this promise is based on a data structure called event struct, and an array of it. So that is what it must return. So you can't return this. So now this, we can call this the events. Okay, now you can then simply return that event. So this to an extent may work, but the data is not structured, so it's going to definitely be problematic. I've devised a way where I can structure the data that flows from the blockchain. So I can say something like const structured event is equal to this. A structured event comes with, let's call it events, is a data type that is of event struct array. Okay, and we want the result that will be returned to also be event struct array. Okay, so at this point, we want to loop through all the events, say .map. Okay, so for each one of these events, you access the you modify its properties. Okay, one of these properties is the ID, so it should have been event.id this way, but we want to make sure that this is a number. Okay, so this is one of the things that we need to modify. There are other things such as the title, which is the string, and all of that. And once all the data are provided, then it will be easy to, structure this up. So this is what I'm going to do. Okay, for now, let's try this. So now we have this here. We also want to sort this out so that the most recent, based on this timestamp, the most recent event will be the one that will be topping. So that is one of the things we want to do. And now let's take this and surround it with this event. So you save that and make sure that this is exportable. All right, so it is ready. Now let's come to this index, which is here. You see this place, instead of generating fake event, okay, you want to say await and this get event, which is coming from the blockchain. All right, remove this fake event, save it, and let's refresh. Oh, we don't even need to refresh. You can see how these data that are coming exactly from the blockchain. You can see this one comes from the blockchain. We just created it, and even though we refresh, the data stays the same. It does not, adjust, disappear, or rewrite itself. Okay, so those are the advantage of using this method. So this is good, but when we click here, the data here will not be in line. This data is not correct. Okay, and so before we get to that point where we work on that data, we want to do something. I want to perform an experiment to see. I didn't plan this. For example, before I do anything, I want to say event. No, say event. Okay, so I want to destructure event and only modify the places that I want to, that I feel like it's really important for me to modify, which is these other ones. Okay, so let's save that and see. Refresh. If it gives an error, know that, yeah, because I've tried it before and the last time it gave an error, but the logic doesn't seem to be very bad. So, but it gives an error. So you want to keep it how it was. Okay, so I'm going to keep it how it was. Save that and refresh again. So these are the data flowing in. So now let's work on this. Let's change some things about it. So this should not be dynamically, generated again. So let it be read data. And to get that read data, we need to say this, duplicate this line of code, say that get event, and you pass, we need the event ID, of course, because you cannot work with it without that event ID. And you want to say get event singular, pass this, this is also singular. This is single, but you know that we can't pass this way. Number is not assignable to a parameter of string. So hold on. If you come to this contract, it's not get event, it's actually get single event, which is this. So let's make sure that we represent that properly first. So get single event. Okay, great. I don't know if this has access to, get. It doesn't have those information. So get single event, that is what we're referencing. But this may seem like it's good, but this is an object. This is not an array. It's not an array, it's an object. So we need to convert it to an array. And you can do that by just putting it inside an array that way. Then this way, structure it properly and return it as an array. So what you need to do is to get the first member of it. And also, you don't want to return an array here. You're not expecting an array, you're expecting a single object. So now this is ready. Let's make it available here. Save it. Come to not to the individual page for an event. So in the individual page for an event, you have this function here that we need to modify. We want to say await, say get event, and you need to call that service, that event service here. You pass in this ID, but of course you need to change this to number before it can pass that scrutiny. Save that. You can even remove. Okay, let's leave it for now. So when you save this, let's refresh this place. You see that this is the real data that is coming from the blockchain now. So this is what we are talking about. So this same read data, if you click on more, click on edit, it takes you to the edit page. In this edit page, these data are also random. So we want to make them, coming from the blockchain itself. Okay, so we need to visit this edit page here. Come to the bottom here. Instead of doing this, let's do it instead. Let's say await, and then get event, get that event, and remove this. Okay. Yeah, so, and this fake data, also remove that, save that, and let's refresh this page. You see that it should get the correct, data now. So you see that it's getting the correct data from the blockchain now. So that is for, resolving that edit place. And let's also see for tickets, do we need to pass in? Okay, we don't need that. So for these, we've been able to read all information concerning this. Okay, we still have one more shot to go. The shot is going to be kind of similar to this. Let me duplicate this function. Want to get personal, event. The event that we created by is a unique person. So it's called get my event. So that is what we're targeting. So let's make this an exportable function as well. Come here, save that. And this is the place where you can update this. It's called personal. So you want to update it here. Get event. Okay, an array of it. You want to say await this get event, my event, and then you get this from the server. So before I say, when I come here, when I come to my personal, listen, what I see is all these randomly generated ones. But once I save, and refresh, you see that those information should also change as well. So all these belong to this account. So it's one account that created all of this. That's why you're seeing all these things here. So this is good. This is good. There's one more thing. Okay. We also have some other things that we need to structure. For example, if you come here, click on a unique blockchain. So you see this recent purchase. This is not correct, and also the one found in this page. So we need to edit that so that we can be reading correct data from the blockchain. And how you need to do that is create another function. We'll call that function called get tickets. Get tickets. And it's exactly the same name here, get tickets. So right now, what I want to do is, the promise that you should return is ticket struct, but an array of it. Okay, so for this ticket struct, we want to call this ticket. Okay, and we don't want to fetch any array, neither do we want to pass this thing as an array. Don't want to call it structured event. So it has its own structure, a little bit unique to the one that we have previously written, but I'm just going to paste this one here. So this is a structured ticket. It accepts a ticket array, an array of tickets, maps through it, and format the record properly. So all this name, ticket cost, timestamps, and all of that, is structure them properly and sort it according to the most recent purchase. Okay, the most recent purchase. So we can use this and override this. So this is returning the right detail now. So we can copy this and export that. So we save this. When you come, not here, but the unique event, you see this place called get ticket data. So we can then say await this get ticket data, and then you get that. Okay, so you pass in the number so that you can get all the ticket that belongs to that specific event. So I'm going to remove this fake data. So we save that. Right now, look at the account that there are here. So when we save this, okay, see that there are no purchase yet here because we created this ourselves. But let's look at the older ones that had been created before we even come up here. So you can see that some of them have purchases. Okay, another place we want to add this is here, okay, where we have all the purchase. Okay, so these are fake purchase for now. Let's come back to this ticket place. Do you see this line of code? I want to say await, call this get ticket. Okay, you get that from the blockchain, and everything should work out just fine. You save this, and you also remove this fake data. Okay, so at this point, all you need to do is to refresh this page. When you refresh this page, the data that is being read is coming from the blockchain now. So there is no more space for stupidity. Yeah, if I should say so. Okay, so everything is real. Everything is returning the right information. So in the next part of this video, we start being able to edit, delete, buy ticket and payout. So I will see you in the next part of this video. So let's be able to update an existing record. So for example, you can see all of these all belong to this account, right? And you want to be able to change some of this information, such as the name. So with that, so that is one of the things we want to be able to do. And to do that, you need to come here, look at this function called create event. Let's duplicate it, call this one update event, right? The same thing that is going to be passed in here. Okay, please pay attention. We're going to require the ID of that event. So that's one of the cool thing about this. We made the ID, like okay, we made the ID optional. So since the ID is optional, it's going to allow us, you can see that, to have an ID later on. So want to update event, everything is the same. All you need to do is to say update here, and you also need to pass the ID. Okay, so yeah, there you have it, and this will be updated and resolved. It's that simple, no big changes altogether. These things are normally closely the same. So let's save that, make it exportable. Now I'm going to come in here, look at inside this edit page. Okay, so we are taking all this information from a form. These are inputs. You see title, capacity, all of these things are coming from a form. And once we submit that form, this function runs, handle submit runs. And exactly the same thing that we did with that creation of an event is basically the same thing that is going on here. The only difference is that when this page is loaded, we basically just load it up with that event data as predefined values. So now let's make this thing function the way we expect it. So we want to say update event, and this update event, you get it from the update event. Come on. Okay, it's coming from this blockchain service. Now we have that. You want to pass in that event. Okay, this event has all the parameters that you need because it's been loaded with this data that is coming from the back end. Okay, so then you need a then process. We can just copy this line here, what we did here, and paste in here. We don't need this reset form. We may need to push this, like let's see the edit form. So it has a place to click back if we want to go back. Okay, or we can integrate that movement that takes us to that specific that specific page that we came from. So we can say router is equals to use router. So at this point, after updating that event, you want to do router dot push, and you want to push to this location called event. We can just copy something like this, copy that link. So we have event here, /event, and then add that event dot ID right there. So this will route it to the right location once it is done creating. So we save this. Okay, and let us try that. Let's say call this Bitfinity ICP Solidity challenge. Okay, and let's make this a round figure, about 2.4 ethers. So let's click on update. So it's saying approving. Click on confirm. You see, it just takes us in here, And that is even much cleaner. When you come here, you can see that this has been updated. So this is great. This is great. There is also another thing, like for example, we would like to delete, want to delete an existing, post. An existing, event. So we'll do that in the next part of this video. Of course, before you can delete, whenever you're deleting, you'll be refunding all these people their money. You understand? So let's do that in the next part of this video. So to handle deletion, there is the ability to delete an existing event. We can just duplicate this update function, call it delete event, and then you can pass in the event ID, which is a number. So the event ID, which is a number, we're not needing all of these, except we can say event ID, and we want to just call on the delete event. Okay, so basically this is it. This is how you delete an existing event. So you copy this and make it part of the exportable members. Now you have that. You save. You come to this single page, where you have all those abilities. In fact, you come to this component, which is event action. And one of the action in this event is the ability to delete an existing event. So this handle delete helps us to delete an existing event, and you can see here that this delete is available right here. Okay, so handle delete is available, and okay, so all you need to do is to hook up that function here, and to do so is the same way we've been working on this. Make sure you import this from the blockchain. All right, and then you pass in this event ID, this event, so you can say event.id. All right, now once you do this, you will need this then statement. Okay, then catch statement. So this then catch statement, we navigate this person to the home page. All right, so this is what we want to achieve. It navigates you to the home page once you've successfully deleted, a post. Okay, so for example, this is one here. Let's check it out again. So we'll say more, click on delete. It tells you, are you sure you want to delete this event? And you click OK. So it triggers you. Click on confirm, and it pulls you off from that platform. So that has been deleted, and all the money that were put into that event has been refunded to the buyers of that ticket as well. So that is the sweet thing about it. It just goes straight forward. So, but there is something you want to prevent. You see, if for example, let's check one of the criteria that you need to obey to be able to delete something. So deleting an event, you must be the owner, and the event must not be paid out. So if the event is not paid out, because if an event is paid out, we don't want that option to delete anymore. So we want to make sure that this is right there. So we can come here to where we have this event. I want to wrap it around the function. Saying this event dot paid out. You want to say it's not paid out. So if it's not paid out, then we display this delete option. So this delete option is still here because it's not paid out. You understand? So that's the funny thing about it. If it's not paid out, then you can refund. So the people have option to ask for you can always refund the money But once you've paid out, then there is no going back. That option will disappear from your from circulation. Okay, so what else is remaining here? Now it is time for us to be able to buy ticket. Okay, so let's buy a ticket, and after we buy ticket, then we'll now have the payout function. Then we'll be done with this tutorial. Basically, to buy a ticket, you need to do the following. I'm going to just duplicate. Let's have this line duplicated for us. So we'll call this buy tickets. All right. In buying ticket, you need that event struct. So event, you need that event, and it's of a type of event struct. You need number of tickets that you're trying to buy. So that will be number. So you need this information. Now we have that function called buy tickets. Okay, buy ticket accepts the event ID. So we can say event.id. It accepts what else again? Let's look at it from here. Buying of tickets. Buying of ticket, event ID and number of tickets. Event ID and number of tickets. So we can pass that ticket here. And lastly, this is a payable function, so we need to pass in a value. The value that we're passing, the value is this event dot ticket cost. Okay, wrap this thing around this, say to we. Okay, so this will help us to purchase a ticket with that price. But please pay attention here. We need to multiply this price with, want to do times the number of tickets. Okay, so yeah, you want to multiply it by the number of tickets to get the accurate depiction, of how many tickets that you want to buy. So with this, you can, okay, yeah. So we're gonna have to do some updates here, but let's just have this thing going for us. So we'll do this here, save this, and then for now it's not gonna work. We're not having that. This thing is supposed to, like when you click here, it's supposed to launch a box, a modal where you can enter the number of tickets that you want to buy. And that component that is responsible for that is called these tickets, buy tickets. Okay, right now buy ticket is at 0, scale of 0. You see, this is the button I'm talking about here. So let's make this part respond to Redux, so that when we click on this, it just launches it. All right, because there are two different components, so we need to find a way of unifying this. Okay, to address this, basically you see that this is what this variable is what is regulating here. So this is what is being manipulated to show or to be hidden. So this value right now, I want to grab it from Redux store. We already have a ticket modal right there. So I'm going to say use selector, and in using selector, it says state. State is of a type of root state. Okay, and you want to say this state dot global state, and then you now say ticket modal. Okay, so instead of reading it from here, we are reading it directly from the store. And the one that is coming directly from the store, if you look here, come to state, see the one that's coming from the store is still exactly the same thing. So it will look like there is nothing I've changed here, which is great. It's okay for now. Now we need to manipulate the value of this ticket modal. To manipulate that value, we have to go to that component where we can find it. The component where we can find this button, this buy button here. So let's come back to this single ticket page. Single event page, and let's look. This is the button right here. So we're gonna orchestrate. You see this set event and set ticket. We want to get the function that will help us to manipulate, that modal. You understand? It's called set ticket modal. Okay. So whenever we click on this button, what we want to do is on click, want it to launch, dispatch a new function, dispatch this function, and let the new value be scale of 100. So I'm going to save that, and let's click on this. You see how it's scaled to 100, but this one doesn't revert it. So we need to revert it on this component by calling on, global actions that's coming from global slice, and want to get that set ticket modal, and also want to say const dispatch is equal to use dispatch. Okay, use dispatch here. So this is what is going to happen. We want a button here that is called close. So you const on close. On close, something happens. This is what happens. We want this to dispatch a new function called set ticket modal, and should scale it back to 0. Okay, so now on close, when you click this button, on click, you should what? Do this on close, you should close it down. And not only that, when we have submitted the number of tickets, we can also close it down right here. So for now, let's come here. When we do this, you see it closes. When you click this, it launches. So this is one of the advantage of using Redux. You understand? So Redux is responsible for this. So now let us be able to click buy, and then we can actually buy something. So come here first, and let's say e.g. 1 to 3. So this is the number of tickets that one. This is minimum of 1, maximum of 3, minimum of 1, step of 1. So let's have it structured this way to prevent this thing from people from buying more than 3 tickets at a go. So at this point, we had already designed this function called buy ticket. So we'll come here and say here, what we want to do is to say buy ticket. Make sure we import this function, and we want to pass this event 1, and want to pass the number of tickets that we want to purchase, which is this. Is a string or a number, so we need to convert that to a number. Okay, so but that's not all. You see, we have this whole then statement thing. All right, so let's come here. All right, so we have this then statement. We don't need to do anything like route it to any place. We just need to be able to handle that resolve or reject. All right, so we'll save that. Now let's try to have another person purchase this. Okay, so I'm going to switch to a new account that I haven't used before, or a new account. It must not be this one. So let's say this account here, connect it. We can call this. We can rename this account to something like buyer account. Okay, this buyer account, we need to reset the activities on it. Okay, clear those activities on it. That is step 1. And then make sure you connect it properly or sign in properly. So sign that. Did you see that that more button is disappeared because I'm not the owner of this post? So I could come here and say I want to buy one ticket, and click on buy and click on confirm. You see that it's done, but this thing did not close and it did not even clear. So we needed to feature that here. So whenever we close, we want to disappear this, and we also want to set tickets to empty string, and we want to close here as well. Whenever we're done, we also want to close here so that will be gone. But right now it doesn't seem like any ticket has been purchased, but when I refresh this, you see that that ticket will then be here. You can see it. Now my problem with this is that I don't want to have to refresh before I see the number of tickets and I see the number of seats that have been taken. I want that to reflect at real time. And for that to reflect at real time, we need to embed that procedure in here. So first thing, we want to get the latest update about the number of the event statistics, like the number of seats that are now available and all of those things, freshly from the chain, to update it, because we're using Redux we've Reduxified this page basically. So when I update the data on Redux, all this information will be recalibrated as well. So I'm going to say const event data. Event data is of a type of event struct. Okay, it's going to be called to await that single event, get event. Okay, and then I pass in this event dot id. Okay, so now I have this event here. I need to update it because whenever any person purchases ticket, the number of seats will increase. So we need to make sure that people are getting the latest updates on it. So to do that, we need to grab hold of that from the global actions that coming from global slice. So we want to do set event singular. Now I want to come here and say store. Okay, the store itself. We're not using use dispatch. We're not using dispatch. We're just invoking the store itself and calling that dispatch method on it. And then we say set event, and then you pass in this new event data there. Okay, so this will update the event, and the number of seats that have been taken will be recalibrated and all of that. So that is for sure. So, but we also want these records, like this number of recent purchase, to also be recalibrated as well. So to do that, you want to say set tickets. Okay. So we want to grab ticket. I want to say const ticket is of a type of ticket struct, an array of it. So we want to say await get ticket, all right, which is also going to be based on this event.id. All right, once we do that, we can grab this and say set ticket, and then you pass in this ticket here. Okay, so here there is a problem. These and these, they are not. I'm trying to understand why this is giving us an error. So we must make sure that these things are converted to numbers. So let's say number here. This shouldn't be a problem because we've already defined it properly here. Oh, look. We are redefining it. So we want to say ticket data instead. Ticket data, and want to pass in here ticket data. So that resolves it, okay, because I've already defined something called ticket here. So this is ticket data. So when we save this, and let's try to purchase a ticket again. So let's say we're purchasing one ticket again. click buy now, and let's see what is going to happen, the behaviors that this is going to now take. So let's confirm this. You see that it just, and you can see it gets you all the latest one. You can see the seats, all of those things are well calibrated just because we added that Redux approach. This is one of the things that makes for a great application, the ability to do all these things under the hood, especially with blockchain being that it's quite slow. So we've been able to achieve this. In the next part of this tutorial, we will then be able to do that payout functionality. So I will see you in the next part of this video. Okay, so this ends in 10 days, so there's no way that we can pay out this particular one, but we can do something. So what we can do here is, I need to switch to the account of the owner, just for manipulative reasons, okay, but you know how it goes. So let's do this. Sign in. I'm going to first change the name of this function. I'm going to say the first annual blockchain summit. Is it submit or summit? Okay, let's just say summit. Okay, so let's update this. This is one of the reasons. So we can, let's just say this is 7. Let's see that. Okay, now let's change it to 7 here. Update, confirm. So we have this now. I also needed to change this, so let's edit this again. We're trying to make sure that we be able to perform payout. So the expiration date, want it to be today, and the time right now is 10 p.m. 10:28 p.m. So I'm gonna move it to 28 p.m. Let's bring it here, 10:30 p.m. Okay, so let's update this, confirm. So in just a couple of minutes, so 1 minute and something second, is going to expire, and so therefore we have the option to perform this payout. Okay, so to do that, we'll need to first create that function that enables us to even pay out. So I'm going to duplicate this function called buy ticket. So I'll have one called payout here, payout function. So virtually, what this payout function will require is an event ID, which is a number. Okay, and we're calling the payout function, and we're just supplying this event ID. That's all we need. The rest of this can be discarded. So when that is done, we also want to do exactly the same thing here and exactly the same thing here. No, we don't need to do anything here. We just need to remove this because it's not necessary. All we need is to recalibrate this. All right, so let's pay out this, list it here, save that. Okay, then we can come to close this. We can come to that action, that's this event action component. You see this handle payout function. So we want to come to this place and say handle payout. So import it from the blockchain and make sure that you do this little thing that we normally do here. Okay, which is this here. But you want to pass in the event ID. So we say event.id. So, and you don't need to push this to any location, but this will be it. This is okay. So at this point, let's save it. Now, this should have expired by now. So it's expired, you can see. So people can no longer buy once it is expired. So you can see this payout function. Okay, so let's click on payout. You can see, are you sure you want to pay out this event? Say click OK and click on confirm. You see, it's been minted, it's been paid, and the owner of this has also received their money, and that is how it goes. So money has been sent, people have been paid out, and all of that. Even when you come here, you'll be able to see that this particular one has been minted, has been paid out. Okay, so we can change this from minted to something like paid out. Okay, so if we come to that event list, so instead of saying something like minted, we can say paid, unlike paid, so paid out. Okay, so we're using that same paid right there. So that is how you operate this. You can even put in some bottleneck here. For example, you want to make sure that you're checking for, before you remove this button doesn't even appear until this is expired. If you want to do something like that, we can say end date. We can use this end date to target that kind of behavior. So we can come here and say that for this payout function, okay, it must be event dot if not, no, sorry, I'm using the wrong addition. So let's manipulate this properly. We're saying that this should only appear if the current date is greater than the end date. So if this thing has expired, then this button should appear. If you check it out, you see that button is no longer open here because it's been paid out already. And also want to emphasize that, and this thing is not already paid out, event dot not paid out, because if it's not paid out, that is another criteria that you should have. But if I haven't saved this now, and you come here for this one that has been paid, okay, you can see here that button will still be there. Okay, so if it's paid out already, then if I save this, then this option disappear and it's only edit. In fact, we don't even need to edit anything at this point. Okay, so we can simply do something like completely just wrap this option, that button. In fact, we should do it in this part where is that event action. So the address must be this, and it must not be paid out event dot paid out. Okay, so these are some criteria where you will not see this. So if it is paid out, it doesn't even appear. You understand that? So that is the cool things about this. For this one that has not expired, you can see that button is not appearing. So at this point, we kind of are done with all the functionalities that this particular project has to do with. And there we go. We've come to the conclusion of this course. So this is the fourth one in the series. I'm telling you, I've been recording all these things in a stretch, so it's been very stretchy. I'm super glad that this has come to an end so far, this particular phase. So, I'm very happy that we have worked on this project. You've seen how the marketplace, eventing, ticketing thing, and NFT minting thing, all in one smart contract and all in one project. You see how we use Typescript, Solidity, Redux, and all of those things together. So it's a beautiful build. I believe that if you immerse yourself with the teachings that has been, encoded in these 4 tutorials, you will get a hang on how to build decentralized application. So with that said, please do not forget that we do have an ongoing challenge running parallel with this tutorial series. Okay, please do check it out. Look at the link below. You can stand the chance of winning a book, 1 to 3 months subscription to Dapp Mentors Academy, and you watch all the videos, all our courses for free that are premium. So this is limited offer. So if you want to capitalize on this opportunity, this is the opportunity. Click on that link below and watch the video that is associated with each one of those tasks and fulfill what it's written there on, and then you get yourself some prizes. All right, so that is just it. I'm very glad about it. Please, if you're new to this channel, please hit that like and subscribe button, hit the notification bell as well, so that you won't miss out on subsequent releases on this channel. So that is it. My name is Darlington Gospel, and I'm here to help you to transition from being a Web2 developer to a Web3 developer. All right, I will see you next time.